Hi everyone, how are you doing? So, how was the test? Everything was good, right? You can hear me. Can you just confirm? Okay, so I think test was good. It means that you have learned a lot from the test, right? So it was the first test, by the way. So don't worry if you have faced it that okay, it was tough test or something. So don't worry about it because it was a very first test. So since it was a first test, so it happens. Like I mean, if you were not able to solve a few of the questions, if you were not able to solve many of the questions, then it is okay because that's how you will learn for the GATE 2024, right? So see, this these tests are there to make sure that you reduce your silly mistakes, right? ओके सो मैनी पीपल आर सेइंग कि सर डिप्रेशन हो रहा है खतरनाक था टेस्ट दैट इज ओके बिकॉज दैट वाज योर फर्स्ट टेस्ट एज अ लाइव टेस्ट राइट आई मीन यू वर अटेम्प्टिंग दैट ओके दैट मैनी पीपल आर देयर एंड यू वर रियली अटेम्प्टिंग इन अ रियल टाइम सिस्टम. So if you felt it that okay the test was tough or test was easy or whatever you way you felt it, the thing is that you have to forget it, which means that whatever you way you are feeling, that is fine because that is a part of preparation. So if you felt that okay test was very tough, then also it is okay. If you felt that test was very easy, then also it is okay. You just need to learn that okay what was the mistakes that you have done and how you could have improved, right? Which means that if you have done something wrong and which you could have done right, then that's what you need to look at. Okay. So yeah, so some people are saying can I target 70 plus? Okay. Yeah, I mean, if your preparation is good, then you should definitely target more marks. Okay. ठीक है. So let's get started. Let's just start the discussion and then we will come back to the general discussion again. Let me just start the technical discussion, right? And then we will come back to the general discussion once again. Let's just start it. Okay. So let's start with the questions from my subjects, which are engineering mathematics and all other questions like CE, DS, and Algo and these things, right? So I hope my screen is completely visible. If there is any issue, you can just let me know, right? You can just let me know if you are not able to see anything. Okay. So let's get started. This is the question number one from my subjects. So which is saying the default storage class for the global variable in C programming. So what was the answer that you have filled? What was the answer that you have filled for this particular question? For the global variables, what is the default storage classes? See, we have done this in the Go classes lectures itself, right? Okay, so those whose results are not showing, it will show. Okay, so those results, those are saying result is not showing. Don't worry, we will take care. Okay, don't worry about it. We will take care like everything from the back end. So we will show it very soon. Okay, in 1 or 2 hours we will show it. Okay, cool. So here many people are saying static. Actually, the answer is wrong. Static is not the answer. Okay, let me just tell you why. So what does this static mean and why static is not the answer? Okay, neither auto is answer nor extern is answer. Actually, none of this is answer. So answer is D. Why that is so? Let me just tell you. Okay, see, what happens that when you write any program, okay, let's suppose you are writing int a and then you are saying this is your global variable, right? So what does this mean? What does this mean? If it is a global variable, first of all, tell me, does this global variable have the static storage? Which means, do you store this in the static memory? Do you store this in static memory? What do you think? Then the answer is yes. Yes, we store that in the static memory. But does this mean that the storage class is static? No. See, if you write, okay, if you say that here, if you say that this thing is as good as, okay, let's suppose you are saying the default, by default you are saying that this thing is as good as writing static, which means you are saying this is this is equivalent to, are you saying this is equivalent, these two are equivalent whenever you write default or you write static? Are you saying something like this? Okay, are you saying something like this? Is this really true? Tell me, can anyone tell me, is this really true? that both are actually equivalent? Can you tell me? The answer is no. See, the both of this are not equivalent. Okay, both of this are not equivalent. So this is no, a big no. Why? Why? Because this particular variable, tell me, this particular variable, is this available to linker? Available to linker? This particular variable is available to linker or not? Just tell me. This particular variable is available to linker, right? Which means that you can write, okay, if you're writing this in some file, and then in another file you can refer this, right? In another file we can refer global variables using string, right? Global variables using extern, right? Which means in if you are writing another file, let's suppose you are having the another file, in another file, okay, I'm talking about the another file. In another file, what you can do, so if you are having the another file, then in another file you can write something like this. You can say that, okay, I want to refer this A, so maybe you can say extern int A. What does this mean? This A basically you want to refer in the next file. Let's suppose this is file 2.c, this is file 1.c, right? You can definitely refer using the extern. You can definitely refer this particular variable using the extern. But suppose you write static. Is this visible? Is this visible in the another file? If you write static here, is this visible in the another file? Can anyone tell me? This is not visible in the another file, right? So this is not visible in another file. This is visible, right? This is visible in another file. So that's why both are not equal. Okay, visible in another file. So if you write static, it is not visible in another file. If you just write this is visible in another file. Hence both of them are not equal. Okay, these both are not equal. If you ask me, are these equal? No, these are not equal. Why? Because this is visible in another file, and this is this is visible in another file. This is not visible in another file. So that is why both of these are not equal. Hence you will say that someone asks you. Sorry, if someone asks you both of them are equal, then both of them are not equal. Okay, then your answer is no. So which means the default storage class is not static for sure, right? The default storage class is not static. You can't just say that, okay, it is as good as saying static. Is it auto? No. Why? Because global variables can't even have auto, right? Global variables cannot have auto. Okay, global variables cannot have auto. Now what about extern? Is this extern? No. Why these two are not equal? If I just ask you, are these two are equal? If I just ask you, are these two equal? Tell me, are these two equal? If I just write extern here, the answer is again no. Why? Because this does not allot any memory. Okay, this is just like, okay, I want to refer to something. This extern does not allot any memory. Okay, so here you have a memory for A, and here you do not have the memory for A. It is just for the reference purpose. Extern is for the reference purpose. Only. Right? Okay. Yes. Akash Manji is correct. So extern doesn't create the memory. So that's why it is neither extern. That's why it is none of these. So basically, if you have something like this, okay, and if I just ask you, let's suppose you have something, some global variable, and if I just ask you whether this particular global variable, can it be static? So if I just give you three options, let's suppose, okay, just to summarize, if I give you three options, can it be static? Can it be auto? Can it be extern? Then what is your answer? See, it cannot be static. Why? Because if you keep it static, okay, if you keep it by default, okay, by default, if you assume that this is static, then it is not the case, because static is not visible, okay, static is not visible outside file. So hence it is not static. Auto, it is not auto, because auto is for local, okay, is for local variables only. Is this extend? No. Why it is not extend? Because extend does not allot memory, okay, does not allot memory, okay, understood? Great. Now let's just continue. Okay, what about this particular question? That was easy, right? So here this n1 and n2 are two variables, okay. See here, this n1 and n2 are, what is the type of these variables? This is struct type variables, right? These are struct type variables. Are these pointers? Tell me, are these pointers? N1 and N2, are these pointers? So these are not pointers, okay, not pointers. These are not pointers, these are just variables. So if these are not pointers, then if you want to access any data of N1, then you will be using dot, okay, you will be using dot. So n1 dot next, yes, that is fine. N1 dot next, that is fine. That is basically next is a pointer, okay, next is a pointer, okay. See here, what is happening here? You can say that n1 and n2 are not pointer, okay, n1 and n2 are not pointer. But if I just ask you, let's suppose if I ask you that, see, what about n1 and 2, you will say not pointer. If I just ask you, what about n1 dot next, since this is not pointer, so you will use dot here, right? You will use dot here. What about n1 dot next? It is a pointer, right? n1 dot next, this is a variable inside the struct node, which is a pointer type variable. So you will say it is a pointer type variable, right? n1 dot next is a pointer type variable. But n1 is not a pointer type variable. So if it is a pointer type variable, then you can use arrow. See here, that here and next dot data, this is wrong, right? Because of this is wrong, because next is a pointer, and then you have to use arrow, okay. Either you use arrow, or what you can do, see, if let's suppose I say struct node star p, and if I want to access any element of this, I mean p will be pointing to, p is basically just a small box, okay, p is just a small box which is pointing to some struct node, okay, some struct node that may be having multiple variables. Right now, let's suppose this is int a, this is char c, and this is basically, let's suppose, struct node star next, okay. Let's suppose this p has to refer to something, so p arrow a, right? Or what is the other way? You convert it, okay, you convert it like a normal struct. Star p means this, right? If p is pointing to this, then star p means this, then star p dot you can write a. So either you write like this or you write like this, right? Both are fine. So basically you can't use directly dot, right? Which means this is wrong. See here, that if you directly use dot, which means if you do this something like this is wrong, okay. You can't directly use dot with the pointers. Dot with pointers is wrong. Pointers wrong. Yes, this video will remain public, okay, don't worry. Okay, so dot with the pointer will be wrong. So basically that's why it is wrong. And why it is wrong? Because of this, right? Why this is wrong? Because arrow is not applicable for the struct type variable. So arrow for normal struct, okay, that's why it is wrong. This is correct because n1 is just a struct type variable, and then I'm using dot, so hence this is correct, okay. So this is correct. So that's why what are the syntactically valid? They are asking syntactically valid, which means gets compiled without any error. So which means it will get compiled. Although it was MSQ type question, still only A is the answer, okay? It will get compiled. I hope you understood. Now let's just move to the next question. Okay, this question. How many of you were able to solve this question? What is the answer that you have got for this particular question? Can anyone tell me? See, the answer here is does not exist. Why? Because see, that's not very tough question. In fact, I will say this is easy question only. There are multiple ways to solve this. Let me just tell you one of the way. See here. See, this is the question, right? So here, if x is going to 1, then we are saying that, I mean, you find out the limit x square 1 upon x square minus 1. Find out the limit of this, right? Now, how you will do? One of the ways is that if you see x tends to 1 minus, which means just lesser than 1, okay? If you see just lesser than 1, can you tell me the value of x square minus 1? Will it be positive or negative? See, this x square will be, if it is 0.9, then x square will also be lesser than 1. So this particular quantity will be negative, right? Will be negative. If you see just lesser than 1, it will be negative. If you see just greater than 1, then it will be positive, right? If you see just greater than 1, okay, limit x tends to 1 plus, okay, 1 upon x square minus 1, just greater than 1, okay, then it will be positive. So since the 1 minus, okay, since you can say from here that limit of this particular quantity, if you take 1 minus and if you take 1 plus, both are not same, right? So which means I can write something like this, okay, which means that limit of x tends to 1 minus 1 upon x square minus 1 is not same limit of x tends to 1 plus, okay, 1 upon x square minus 1. Hence limit does not exist, okay, limit does not exist, right? Okay. Yeah, so basically this is one way to solve it. Another way could be, since it is 0.0, what you can do, you can use a L'Hopital rule, right? L'Hopital rule. So basically what this rule says, that you can basically use this rule. You can differentiate this, differentiate this. So what you will be getting, 0 upon 2x, right? And now again it is 0.0. So if you differentiate it, you will be again getting 0 upon 2x will be 2, right? 0 upon sorry, it will be 2x. Just a second. So sorry, it is not 0 upon 0. I'm sorry about it. This is you can't apply the L'Hopital rule directly, right? Okay, because it is not 0 upon 0. Anyway, don't worry about it. So basically we have solved like this, and it is limit do not exist. Limit do not exist, right? Okay. Yeah, it is not 0.0. Yeah, sorry, I just overlooked it. Now let's just solve this. This is a very nice question, right? This is a very nice question. Okay, let's just solve this. What this is saying, how many of you, by the way, were able to solve this question? This was easy and nice question. How many of you were able to solve this particular question? This question is saying, just very easy question. It is saying, in an LR1 parsing process, if the parser is currently in the state involving LR1 item this, which means they are saying, let's assume that parser is in the state which is involving, okay, which is basically in the state which is involving this particular LR1 item. A gives AB dot C comma D, and they have further specified that A gives AB dot C is the core item and D is the lookahead symbol. What element should be there on the top of the stack in this instance of parsing, right? So what is the answer? This is easy question, right? How many of you were able to solve it? I'm not promoting goclasses here, but I'm 100% sure that goclasses student who have watched our lectures must be able to solve this, right? And also there are three lectures about the parsing, 3 or 4 lectures about the parsing that are publicly available in the goclasses channel, okay? Parsing lectures. You should definitely watch it, and then you will be able to solve these kind of questions very intuitively. It is very intuitive question. What they are saying, that if you are in this state, then what must be on the top of the stack? See here, that if you are in this state, then it means what? It means what? That you have already seen, see, you have recently seen AB, right? Which means in the stack, there might be anything, but on the top of the stack, you just have seen A, you have shifted A, this is shift move, right? You have shifted A, and then you have shifted B. So AB must be on the top of the stack, okay? This is on the top of the stack, okay? And there could be something else also. You might have seen before, something else before also, right? So there could be something else also. So on the top of a stack, this is just AB. Now, if you're very particular about only one character, then it is B. So that's why this is the answer, right? Okay, I hope you understood. Okay, so what was there here for the confusion? See, some students are saying that I got confused here, right? I got confused here. So what is there in the confusion? See, if you are, let's suppose, having A gives, let's suppose, dot A, B, C. I'm just saying, okay, let's suppose D. Let's suppose you are having this state. Now, once you see A, where you will go? You will go to A gives A dot B, C, comma D, isn't it? You will go to this state, assume, right? Now from here, let's suppose you see B. Okay, from here, let's suppose you see B. Then where you will go? If from here you see B, then you will go to which state? Tell me. You will go to A gives AB dot C comma D, isn't it? See how you have reached to this state. Let's not worry about it. Which means there must be something in the stack using which you must have reached to this state. See, if you are not currently understanding that what I'm talking about, then I strongly recommend to watch our lecture, which is basically the lecture heading is okay, really understanding LR0 parser. Okay, you just Google this out, really understanding. Or can anyone ping in the comment section currently? Okay, that lecture link, really understanding LR0 parser. Can anyone just ping in the comment, so that if anyone has not seen that lecture, they can definitely see this lecture. This is the most needed lecture to understand the parsing. Okay, most needed lecture. So basically, once you see this lecture, it will be very intuitive that okay, using some input, you might have come here, and then after that, on the top of the stack, see, using some input, you might have come to this state, and then this is the input, and then on the top of a stack, it must be A and then B. And if you're very particular that what is the one character, then it is just B. Okay, it is just B. So I hope you were able to solve this, right? It is easy question only. Now let's just see this question. This question is from linear algebra, and this question is also I guess it is easy. See, till now we have I think we have solved 3-4 questions, right? I don't remember the exact number. This question, was it tough? Tell me, was it tough? Wasn't it just a logical question that okay, you can't put static, you can't put auto, right? Was this tough? Was this tough? This was also, I think, easy. Was this tough? Was this tough? Tell me. I think this was also easy. Okay. Now let's just see. Is this tough? Is this tough? So basically the questions were, I will not say easy or I will not say tough. It was just conceptual questions we were asking, right? Just conceptual 1 mark. Okay. So till now we have just seen conceptual 1 mark questions. Let's just see this particular question. Is it really hard? Let's just see. See, many people are saying that AIMT was hard. Let's just see if it is really hard. Okay. Let's just see. So what this question is saying here, they are saying that okay, so they are saying that suppose m is greater than n, then rank of the augmented matrix cannot be larger than m. So which means let's just assume any dimension. Okay, maybe you can assume some dimension to be, let's just say that you are assuming m equal to, for this particular sake of option, let's just say there is 3 into 2, which means there are 3 rows and 2 columns, right? So basically there are 2 columns in the matrix and 3 rows. Okay, 3 rows. Now they are saying m is greater than n. Yeah, m value I have taken 3, n value I have taken 2. The rank of the augmented matrix. See, if you augment it, then there will be 1 more column, right? Then at most this rank could be at most 3. At most m or at most 3, right? At most 3. So can it be larger than 3? See, is 3 larger than 3? See, this A rank is, let's suppose, is okay. By the way, the rank of A will be just 2, right? Rank of A will be 2, and then if you augment it, then augmented rank, okay, augmented rank will be 3. Okay, maybe it is 3. So I am saying that if you have, let's suppose, m rows, and if you augment it 1 more, okay, it may be possible that you finally might be getting m, but it is not larger than, okay, cannot be larger than. So what they are saying, the rank of the augmented matrix, let me just go to the next page. See here, the rank of the augmented matrix. See, they are saying A m cross n. So here this is 3 rows and 2 columns, right? 1 2 3 rows, 1 2 3 rows and 2 columns. Now if you augment, let's suppose this rank is 2. This is a full rank. Full rank means, let's suppose, whatever the maximum possible rank is 2. Okay, this is 2. Is this possible? So suppose m is greater than n, the rank of the augmented matrix cannot be larger than m. Okay, cannot be larger than m, right? So if you add one more, what could be the rank? At most 3 you can get, right? Is this larger than m? No, right? Because m is just 3, so it cannot be larger than m. So that is true, right? That is true. So anyway, like, this is very intuitive question. I mean, that is true, that cannot be larger than m. Okay, what about the next option? Let's just see. What about this option? Can you tell me that suppose A has the full rank, okay, which is minimum. Full rank means whatever the best possible rank is there, okay, based on the dimension, which is minimum of Mn. Then Ax equal to B always have the solution. What do you think? See, suppose that you have something like this, okay. Suppose you have something like this. You have again, let's suppose 2 columns and 3 rows, okay. 2 columns and 3 rows and 2 columns. Let's suppose this rank is a full rank, okay. Rank of A is full rank, which means 2. So it may be possible that you may be having B, which is not a linear combination of this. Tell me, if you have seen my linear algebra lectures, tell me, do these two vectors fill that space? Do these two vectors always fill that space R3? So it may not be filling R3, right? May not be filling R3. May not be filling. If you have seen my lectures, then I'm telling based on that only, which means that those intuitions. Otherwise you can do your own method. But I'm just telling the intuitively. So they may not be filling R3, right? So there can be B which is outside R3, right? Outside R3. Sorry, outside this space. Okay, whatever they are filling. So outside this space. So outside. This is called, by the way, column space, but you don't need to worry about it. So what I'm saying, that they do not need to fill. They do not need to fill R3. There could be some vector which is in R3, but not in this, right? Not in this. So hence this is also false, right? Hence this is also false. So this is false basically. If Ax equal to B has a solution, then Ax equal to 0 has a unique solution. Can anyone tell me what does this mean? See, they are saying if Ax equal to B has a solution, right? What does this mean? It means that it may be possible. Let's suppose you are having some matrix. It may be possible. These are the two vectors again. This is, let's suppose, again in R3. Okay, suppose it has a solution. Suppose this is a B, which is basically just maybe one of them. Maybe, which means it is possible that this is U and this is V, and V just U. Then what is the solution here? 1 0, right? 1 0. You might know this already. I mean, these things, right? What I'm saying, that this B maybe one of them, or I mean, with this B basically is a solution of this. Does this mean that these two vectors are Ax equal to B, Ax equal to 0 unique solution means these two vectors are linearly independent? Does this mean? No, right? These two could be U and U only, right? Ax equal to 0 does not have to be unique solution. So Ax equal to 0 has a unique solution means what? That columns of A are linearly independent. Okay, so does these have to be linearly independent just because B equal to U? No, right? No. So that's why this is also false, right? This is also false. What about this? If Ax equal to B has a unique solution, then A has to be invertible? No, right? So basically, let's just see this. If Ax equal to B has a unique solution, what does this mean? That columns of A are linearly independent, right? But it doesn't mean, see here, see, first of all, that A may not be square matrix, right? May not be square matrix. Okay, which means it may be possible that Ax equal to B has a unique solution. Let's suppose this is 3, this is 3, this is 3, right? These could be linearly independent. Linearly independent means Ax equal to B will be having the unique solution. Okay, this is B. Now linearly independent means that you just have one combination. Okay, see, unique solution means that you just have one combination to produce this B. What does this mean? It means that these are linearly independent. Does this mean that this particular matrix is invertible? First of all, it may not be the square matrix, right? May not be the square matrix. So hence this is false, and this is also false. So only A is the correct answer here. Okay, see, I have just solved intuitively. You may use your own formulas and so on, right? We have taught the complete linear algebra course on the YouTube. Okay, so complete linear algebra course is on YouTube. Okay, you can watch it later. Okay, I mean, maybe after gate if you want, you can watch it. Okay, how many of you, by the way, watched this linear algebra course? How many of you watched this linear algebra course? Can anyone tell me how many of you already watched? Okay, so I think most of you have watched, right? Great. So what are the answers here? Answer is only A. Okay, only A is the answer. Cool. Now let's just go to this particular question. What they are saying, the lecture analyzer uses the following pattern to recognize the T1 and T2, T3. I mean, these are the three tokens. T1 is just having the regular expression C, T2 is having the regular expression B, and T3 is having the regular expression A star, B star, C star. Okay, this particular question, I mean, almost same, exactly same. I can say this particular question has been asked in GATE. Do you know about it? This particular question has been asked in GATE. Do you know about it? Okay, I mean, almost same. Obviously, there's a difference. Almost same is GATE P by Q. Right? Okay. Okay. Let's just see what they are saying. So this is the question number. I mean, in the exam it might be any question number, but after the exam it is showing that question number is 16. Okay. Let's just see what they are saying. They are saying that if you are having the strings like B, and then you are having A B C, right? A B C, and then you are having A B A. Okay. A B A. A Okay, A B A B C C C. Here the lecture analyzer uses the longest prefix match, right? This uses the longest prefix match. So what does this mean? What does this mean? It means that see here, this B is matching to whom? See, this B, this has to start with A, this has to start with B, this has to start with C. So basically, if it is starting with B, if something is starting with B, you are 100% sure this is T2, right? Because this has to start with C, this has to start with B, this has to start with A. So if this is starting with B, this is T2 for sure. Now if it is starting with A, this is T1, but T1 is saying you just keep on taking A, B, C, okay? I mean, till whatever length it is possible. So A, B, C, okay? This is T3 basically. Now if it is starting again with A, B, okay, C is not there, no problem. This is again T3. Now if it is starting again with A, B and C, okay, this is again T3, right? So T2, T3, T3, T3. So what is the answer? C is the answer, right? C is the answer. Okay. Tell me, were you able to solve this question? Was that MSQ? I don't remember. Was that, I mean, I don't think it was MSQ, right? Even if it is MSQ, then also, I mean, C is the answer. Okay, great. Now, let's just go to the next question. What they are saying, consider a system with page size this. So they are saying that you have a system with some page size, and then page table is given to you, okay? Page table is given to you, something like this. Then they are saying that the first column represents in this page table, this is a virtual page number, this is a physical frame number or something like that, right? What is the physical address in decimal corresponding to virtual address 999? So which means if 999 is your virtual address, then what is the corresponding physical address? That's what they're asking, right? Physical address. Okay. See, what do we do? You have your main memory, isn't it? What do? You divide this main memory into frames. Right? You divide this main memory into frames, and you have your virtual memory. Right? Your virtual memory. You divide this into pages, isn't it? You divide this into pages. Now let's suppose this is frame number 0, this is frame number 1. Okay, I'm just writing the frame numbers. Okay, 0, 1, 2, 3. This is page number. Okay. Okay, page number. This is 0, 1, 2, 3, something like this, right? Now this page number, okay, some of the page number, maybe some page will be going to some frame, right? Now, if some address is given to you, maybe this address is given to you, they want to ask you what is the physical address, right? What is the physical address? Let's suppose you get to know that this particular page number, okay? First of all, let's suppose you get to know this particular page number is mapping to the frame number 3. Then what does this mean? Okay, suppose you get to know that this particular page number is mapping to frame number 3. Then what does this mean? Can anyone tell me how many bytes are there just to start the page number 3? See, how many pages are there above the page number 3, or the frames are there above the frame number 3? These are the three frames, right? These are the 3 frames above the frame number 3. So if someone asks you that what is the address of the first byte here, then what you will tell? you will say, see, the address of first byte here is 0, address of the second byte here will be 1, then 2, and let's suppose this particular frame number, the frame size, let's suppose, is 500, right? Then 0 to 499, these many bytes are there, right? So basically, if someone asks you that what is the address of first byte here, you will say 500, right? What is the address of first byte here? You will say 500. So basically, if someone asks you what is the address of first byte here, you will say 1000. What is the address of first byte here? You will say 1500, isn't it? Which means, as you know that 1500 bytes are above it, or maybe in other words, 3 frames are above it. So 3 frames means frame size is 500, so 1500, right? So 1500 bytes are above it. So 0 to whatever 1499, okay, these many bytes are there. So the first byte will be 1500, isn't it? So what I'm trying to say is that if someone give you that, okay, see here, that this is frame number 0, 1, 2, 3 or 4 or whatever, right? Let's suppose someone give you this particular structure. Someone asks you what is the address of first byte here. You will say, see, above me, since I'm the frame number 4, above me there are 4 frames. That is why let's suppose whatever the frame size, okay, that is why these many bytes are above me. 4 frames, or maybe 4 into whatever the frame size, are above me. So this is the address of this byte, right? So hence, if someone is asking you that, let's suppose that for a given virtual address, okay, what is the physical address, then what you will say? You will say, okay, first tell me what is this, let's suppose this is the virtual page, okay, what is the physical page? If you just tell me the physical page, then first of all I will go here, which means I will do one thing, okay, getting that physical page, okay, suppose somehow I get to know the frame number, okay, once I get to know the frame number, and then into frame size, I will do frame size. This will tell me what? This will tell me the starting address, then plus offset, right? Then plus offset, which means how much down I need to go from here. So basically, people do in binary, and this is the question from the decimal, right? That's why some of the people get confused here, right? But this was not a tough question actually. This is just easy question. They are saying that your virtual address is 999. So first of all tell me what will the page number? See, in each page you are having 500 bytes, right? If someone asks you that virtual address is 999 or something, then it means you can divide. Let's suppose if someone asks you that virtual address is 500, then what is the page number? You divide 500 by 500, then page number is 1. If someone asks you virtual address is 501, what is the page number? Page number is again 1, right? It is just a division. See, someone say virtual address is, let's suppose, 600, okay? Then what is the page number? You just find out page number first. What is the page number? You will say, okay, see, in one page there are 500 bytes. Then this 600 virtual address must be in the second page, or maybe the number wise you can say this is 0, this is 1. So this is basically you can say this is page number 1, right? Page number 1. Obviously this 600th byte must be in the page number 1, isn't it? So how you found it out? You have divided the 600 divided by 500, and whatever the division you are getting, okay, 1 point something, that let's not worry about it, but yeah, this is your page number. Once you get your page number, what you do? You find out the frame number, right? So here 999 was given to us, virtual address is 999. Now can you tell me this 999 will be in which page? If each page is having 500 bytes, this 999 will be in which page? This 999 will be in which page? You just divide 999 divided by 500, right? Okay, so how many times you are dividing? One time only, right? One time only you are dividing. So this is the page number. Okay, this is the page number. Which means you also know from 0 to 499. This is here from 500 to 999 basically, right? From 500 to 999. This is the page number 1, isn't it? So once you know the page number, you got the page number, right? Now you tell me what is the corresponding frame number? What is the corresponding frame number? This is 11, isn't it? So now you know that, okay, see here that this particular page number 1 has been stored into the frame number 11, isn't it? So basically what you know here, that you have got you have got, let's suppose this is page number 1, right? You have got the page number equal to 1. From the page table you got to know, okay, this has been mapped to the frame number, how much? This has been mapped to which frame number? From the page table you must have got to know, right? This has been mapped to the frame number 11. So this is the frame number 11. What does this mean? That there are 0, 1, okay, I mean there are basically 11 frames above me, right? There are 11 frames above me, 11 frames. So what is the first byte here? What is the first byte here? You need to multiply 11 into frame size. This is the first byte here. Plus how much down you go? No, you have to go. How much down you have to go? That is the offset. So how to find out the offset? Plus offset, right? Plus offset. Can anyone tell me how to find out the offset? Offset will be, see, generally you do in the binary. That's why you might not be habitual of this decimal, but you should know how the things are happening. Okay, for more detail you can watch our I think on the YouTube I have taken one session. You can watch that session, okay, and then you can relate this binary with the decimal, but I can take one more session, don't worry about it, right? So here the offset will be this 999 was your virtual address. For that you need to take a mod of 500, right? That how much, okay, how much down you need to go. So this will be 499, okay? So this will be 499. So which means 5500 plus 499, and your answer is 5999, okay? Which is 999. This is your answer, okay? Okay, is this okay, everyone? So that's how you should be able to solve this question, right? Now, what is the answer here? Answer is 5999. Okay, this is your correct answer. See, this is a 1 mark question. The reason was that it is very easy question if you just know that how to solve in the decimal also. If someone give you, let's suppose in the binary. See, here I'm just asking you, given this virtual address, okay, I'm just asking the physical address. Let's suppose if someone give you in the binary, okay, instead of decimal, if someone say that, okay, I give you some binary, okay, let's suppose this is virtual address. Can you tell me in binary, can you tell me how to find out the physical address? You will say most probably yes. How? You will keep this, okay, whatever this the offset or the page offset, right? Whatever you say it, page offset, you will keep this as it is. I mean, let's suppose there's a based on that that number page size, you will see whatever the page offset, you will keep it as it is, which means you will copy the page offset as it is, okay? And this is the page number, right? So you will copy the page offset as it is, and then you will say that, okay, for the page number, since this is a page number, you need the frame number, right? Using what? Using the page table, right? Using page table. So using page table, the page number, what is the particular frame number, you will append it here. So this is basically using page table, right? This will be the frame number, right? So basically if someone give you in the binary, then that's how you need to solve it, and someone give you in the decimal, then that is how I have shown that how to solve it. Basically both are same. I mean, this binary and decimal things are same. We have explained this in the lectures also, that why both are making sense, right? Okay. So let's just go to the next thing. Here, by the way, for this binary to work, the page sizes generally are in the power of 2. Here I have given the 500, so that's why even if you convert in the binary, it might not work as it is, right? Because in the operating system, in the real time system, the page sizes we take in the 2 power. That's why this binary and this decimal conversions are exactly same. Okay. Now let's just see this particular question, which is just asking about the shape sequence. So if you have really understood, okay, if you have really understood that what is the shape sequence, then you must have solved this question. Okay, Prashant is saying that I have solved using the binary and I got 6119 or something. See, Prashant, if you have solved using the binary, then that's what I'm saying. This might not have worked because this binary and decimal are making sense whenever this page size is power of 2. Okay, but here the page size is just 500, which is not power of 2. It is not in power of 2 directly. So that's why the page offset you can't find like this and so on, right? So that's why you might have got the different answer than the real answer, right? Okay, because the page size is not in power of 2. Okay, so see here what they're saying. This question is basically very nice question if you have really understood that what is a safe sequence. If you have not understood, don't worry, let's just try to understand that. So what is a safe sequence? Okay, that's what we need to understand. See, they are saying the safe sequence is given to you. The safe sequence, they are asking what is the safe sequence basically. Regarding the safe sequence, what is correct? If you are given that this is a safe sequence, does this mean that this is the execution sequence also? Tell me, are the safe sequence, if this is the safe sequence which is p1, p2, p3 till p10, if this is a safe sequence, then you just tell me that is it the same as the execution sequence also? Execution sequence. What do I mean by that? It means that in this way only you have to execute. There is no other way. Do you think in this way only we have to execute? There is no other way. No, right? It might be possible. First of all, it might be possible in this question. It is not given that there is only this is a safe sequence, right? Which means first of all there are multiple safe sequence possible. Okay, we will eliminate that possibility, don't worry. Like, I mean, even if they give you only safe sequence, this is the only safe sequence possible, then also the reasoning will be same, but you can solve it in the easier way. I'm just saying you can solve it in easier way, that they are saying in this way only you have to execute. No, right? First of all, there may be multiple safe sequence, and the second thing, which is more important reason, is that this is just a safe sequence. This is not the execution sequence. That's what you need to understand in this question. The safe sequence and execution sequence are not same. Then what does the safe sequence even mean? If they are not same, then what does the safe sequence even mean? Right? If we are not executing in this order, strictly in this order, then what does this mean? Okay, can anyone tell me? Can anyone tell me what does this even mean? See here that this safe sequence mean that if you allocate, okay, if you allocate in this order, p1 is asking, let's suppose p1 may ask, let's suppose at max, okay, in future, okay, I'm just asking, I'm just writing future need. Let's suppose p1 in future can, let's suppose, may ask for 5, okay, p1 in future may ask for 5, p2 let's suppose 10, p3 let's suppose 3, or and so on, right? Then even if they ask for maximum possible, okay, even if they ask for maximum possible 5, and then 10, and then 3, so this is the safest sequence, which means you can fulfill in this sequence. You can, even p1 ask for 5 at one time only, then you can give, and then p2 you can give, basically, which means that this is definitely the execution sequence. I mean that you can execute, but do you really have to execute? Do you really have to execute in this order? Then answer is no. Maybe you can execute p2 first if p2 is, let's suppose, p2 is asking. Okay, see. Let's suppose this is the current safe sequence. Okay, current safe sequence. Now. Okay, now p2 is asking. Okay, p2 is asking, let's suppose, two resources. Okay. Now what we will do? We will temporarily, okay, we will temporarily, sorry about the spelling, so allot, which means, I mean, just for our sake of purpose, okay, just for our sake of algorithm running, we will allot and see if after giving p2 as two resources, then also it is safe or not. If it is safe, let's suppose after giving two resources to the p2, see, currently this is safe, but p2 is asking for two resources. Can I execute p2? Okay, tell me, can I execute p2? If after giving two resources it is still a safe, I mean, you have the safe sequence, right? It is safe state, right? Then yes. Right? Understood? So basically, see, for this particular question, you really have to understand what is the safe sequence, and then you can immediately do this question immediately. See, the safe sequence is not the execution sequence. What you do, if someone asks you that, let's suppose this is currently the safe sequence, and someone asks you, can you execute can you execute P2 asking for two resources or some resources, right? I mean, for, let's suppose, two resources or five resources or something, right? Let's suppose I'm just writing for the sake of example two resources. Then what you will do? Check. You just check, right? After it, you check. Okay, check if system is safe after doing it. If yes, then execute P2, otherwise don't execute P2. Yeah, right? So basically, there will be two answers, yes, maybe no. If yes, then execute P2. Execute P2. If no, then don't. So the only thing is I'm trying to convey that you can execute out of order if it is in still the safe state, right? You can execute out of order if it is still in the safe state. Okay, so that is why it is not strictly, it is not means that it strictly have to be executed in the same sequence. No, that is why this is wrong. Okay, now interestingly, this option is also very nice option. What they are saying, the banker's algorithm will always allow P1 to be executed regardless the resources it requires, as long as it is under the pre-declared need. See what they are saying, that if the safe sequence is given to you as above, and then they are saying that banker's algorithm will always allow at least P1. Okay, yes, obviously. See, what does the safe sequence mean? You have to understand this, then only you can solve this question. What does safe sequence mean? If the safe sequence is this, then what does this mean? Even if P1 asks for the maximum, okay, even if P1 asks for the maximum need, okay, maximum need, even if the P1 asks for the maximum need, then also I can do it, and then I can fulfill P2 maximum need, I can fulfill P2 maximum need, and then I can fulfill P10 max, I mean P3 P and so on, and then P10 maximum need. So I have already taken care that into the account that even if P1 asks for the maximum need, I should be able to give it. So that's what they're saying. The banker's algorithm will always allow. Yes, it will always allow process P1 to be executed regardless of the process, the request, regardless of the resources it requests, right? I mean, however number of resources that P1 is asking for, okay, whatever number of resources P1 is asking for, as long as obviously it has to be under the pre-declared need, as long as that is there, then you should be always allowed to execute this P1, right? Because that is what safe sequence means. Safe sequence says that, okay, I will be allowed to do this P1 even if the P1 asks for the maximum, even if P2 asks for the maximum, then after P1 I should be able to execute this P2. So hence this is true. Okay, this is true. If we allow P2 to be executed before P1, then system will always lead to deadlock. No, again see, this is the thing. If you allow P2, maybe you can execute it, depends and after allocating, okay, after allocating temporarily, basically, okay, we are just checking, after just checking, then if it is in the safe, then you it doesn't mean that it will it will always lead to unsafe or deadlock. You can if it is in the safe. Okay, so basically that's why will lead to deadlock, will lead to unsafe state. That's why these two are wrong. Only B is the correct answer. Okay, only B is the correct answer. Even though it was multiple select, again B is the only correct answer. Okay, let me know if you have understood this particular question. Really nice question, just conceptual. Okay, just plain conceptual question. See, don't worry if you have not studied these things before. Okay, don't worry. Why? Because you have now you have got the idea that what is the safe sequence. See, the idea of the AIMT is that we can convey the concepts to you. Okay, so this is the idea of the AIMT. Okay, we should be able to convey the concepts to you. Now you know what is the safe sequence, right? So idea of this question is to tell you that what is the real meaning of the safe sequence. See, many coaching teachers, they just tell you that, okay, this is safe and so on. I mean, they don't tell you the real meaning of the safe sequence. And if gate has decided, okay, if gate someday gate might decide to ask some type of question, then they, most of the aspirants might get confused. Why? Because if you don't know what is the real meaning of the safe sequence, then you won't be able to solve these kind of questions. Okay, understood? Now let's just go to the next question. Okay, let's just go to the next question. So what they're saying, this question is from computer networks, by the way. Okay, so what they're saying that A is connected to R1 and R1 is connected to B, right? Now this link can drop the packet with probability 0.1. This link can drop the packet with probability 0.2. Now what is the probability that packet from A to B will not reach, right? Does not reach. See, if you solve like this, that okay, the probability that it doesn't reach, then if you solve like this, that see, that probability doesn't reach to R1, probability doesn't reach to R1 0.1, and the probability doesn't reach to B, R1 to B. This is the probability that is the answer. Then this is wrong. Right? This is wrong. And why? What is the reason behind it? See, if you do something like this, then A is the wrong answer, by the way. Let me just tell you why. You are saying that it doesn't reach here. If it is not reaching here, then how you are saying it is not reaching here? I mean, you have to take two cases from here itself, right? What do I mean by that? See, let me just tell you that if you are doing something like this, then why it is wrong? See here, you might have done combinatorics and permutation combinations questions. Maybe you have the idea, but still let me just tell you. See, from A it might go to successfully to R1. Okay, R1 successfully to R1. It might not go to successfully to R2. What is the probability that it will go to successfully to R1? 0.9. This is the probability 0.1. It doesn't go to R1. If it doesn't go to R1, then automatically it doesn't go to B, isn't it? Automatically it doesn't go to B. So this probability, either with this probability it doesn't go to R1, or if it is going to R1, then you are saying what is the probability from here? Okay, from here it may go to B or may not go to B, right? It may not go to B, it's a 0.2 probability. So what is the probability from here? It doesn't go to B, so you need to multiply all the path probabilities. So which means that 0.9 into 0.2, which means 0.1 plus 0.18, which is 0.28, right? 0.28 is the correct answer here. You need to take the cases. Okay, this is one way to solve it, right? This is one way to solve it, right? This is just one way to solve it. Another way to solve it like this, that this doesn't you are saying that what is the probability it doesn't go to B, then you tell me what is the probability it goes to B. Then the probability it goes to R1 is basically 0.9, and into the probability it goes to R1 to B is 0.8, right? So this is the probability that A to B is success. A to B success is the probability 0.72. And then if it doesn't go to A to B, then 1 minus 0.72, right? 1 minus 0.72. So there are two ways to solve this particular question. Okay, 1 minus 0.72 is basically 0.28. So hence D is the correct answer, right? Okay, great. So many people have got it right? 0.28 is the correct answer here. See, just the major mistake that students might do is this. That's why I have put A as the first option. Okay, this is the major mistake that students might have done. That they might have thought, okay, it doesn't go to R1 and it doesn't go to B. See, for not case it doesn't work like this. If it doesn't go to R1, then how you can say and it doesn't go to B? If it is not even reaching to R1, then how you are reaching it to B and doesn't go to B like that? This kind of reasoning is wrong, right? So hence either you make cases like this, or maybe simply you can do, okay, they are asking what is the probability that it doesn't go to B. You say what is the probability that A to B is success. This is easier to find, which is basically 0.9 into 0.8, because this is the drop probability 0.1, the drop probability 0.2. So what is the probability it go to A to R1 and R1 to B? This is the probability. Then A to B is a failure, then it is 1 minus 0.72 is 0.28 is the correct answer, right? So this is one way to solve it. Okay, let's see this question. What they are saying: the sender needs to send packet of 4800 bytes, right? 4800 bytes is the packet length, which includes IP header of this, and empties are given, right? So basically you are saying 4800 including the IP header, which means minus 20, which is how much? 4780, right? This is 4780 bytes that you need to send. Okay, so if you want to send this 4780 bytes, then what you can do? 4780. The first link that is basically MTU of 1500, which means 1480. I mean, if you exclude that IP header, so basically it is 1480, 1480, 1480, and then I think this will be 340, right? Can you just do the math? Is this correct? 1480 into 3 plus 340. Yeah, I think it is correct. And now you need to send to the MTU of how much? Let me just see. 576. So now you need to send to the MTU of 576. Then what does this mean? It means that if it is 576, then 576 minus 20, it is 556, right? Okay. So now you need to divide it into how many parts? See, by the way, this 556 is not directly divisible by 8. So maybe you can do you can say that let me have, I mean, 552. So basically 552, and then what will the remaining one? 552 into 2. Okay, let me do the math. This will be, I think, 376. Okay, so 3 packets out of it, 3 packets out of it, 3 packets out of it. So 9 packet, and it will anyway go 9 plus 1. So how many packets? 10 packets. Okay, 10 packets. Great. So this will receive how many? 10. Easy question. That's why it was a 1 mark question. Was it tough question? Tell me. Was this question a tough question? Do you think this question was really a tough question or something like this? I don't think, right? I mean, I think this was easy question only. Okay. Suppose you have the priority queue implemented. Okay, let's just solve this question. What they're saying, that you have a heap and you want to perform an insert and n delete, right? And n delete min operations in such a way that binary heap never contains more than root n elements. See, what is the cost of insert? Heap insert element log n, right? Log n, I mean I'm writing capital N, I mean that whatever the number of current elements, right? And what is the delete min cost? It is again log n, right? It is again log, I'm writing capital N just to tell you that, okay, it is the number of elements in the heap. Now they are saying that you do n of this in such a way that you never contains more than square root of n elements. So basically you will be never needing more than this cost, right? Log root n. Asymptotically it is same as log n. So basically you need to do n insert and n delete, right? So for n inserts, how much cost you will be taking? For n inserts, n log n, plus for n delete, n log n, 2n log n, right? Okay, 2n log n. So which means what is the answer? B is the answer. I mean, you will never be taking more than 2n log n. This is when you are having see, they are saying you are having at most root n elements. This is the maximum cost. Okay, this is the maximum cost you will be taking, which means your cost will be lesser than equal to n log n or 2n log n or whatever, right? This is the maximum cost that you will be taking. So this is, they are saying it will be lesser than equal to root n. No, root n log n, no. Yeah, less than equal to n log n. And square root of log n, no. Similarly, no. Let's suppose option is order of let's suppose n square. Then option is also the answer. See, if order of log n, if it is let's suppose MSQ, and I mean MSQ or MCQ does not matter basically. If it is MCQ and option is also in the option, then they will give the marks to all. Okay, they can't give two options like this, right? Okay, or they have to say the tightest bound. Okay, or they have to say the tightest bound. Anyway, what I'm trying to say, that if this particular is the answer, then order of n square is also the answer. I mean both if the option is let's suppose order of n square, then this is also the answer. Okay, if this is the answer. Okay, now let's just go to this question. This question is interesting one. How many of you were able to solve this question? Tell me. How many of you were able to solve this particular question? What this question is saying is that they are saying that you have a weight, okay, which is vu, like they are saying that you have a directed graph, and here in the directed graph you are changing the weights. So it might so happen, let's suppose the shortest path, okay, let's suppose the earlier, okay, before changing the weights, let's suppose the earlier and the now, okay, now what is happening, the earlier the shortest path like this, maybe the earlier it might be possible the shortest path like this is one, and this is, let's suppose, two, or maybe let's suppose three. Then what is the shortest path? Shortest path is this, right? Now this. Now let's suppose I add, let's suppose some numbers, maybe I add or subtract, basically does not matter. Let's suppose I add 5 to everything. Now can you tell me what is the shortest path? Is shortest path changing or not? This is 12, this is 12, this is 8, right? This is just 8. So the shortest path changed, right? Shortest path changed. What is the reason? Because earlier the shortest path is basically having two edges. Now the shortest path is just having one edge. Basically what I'm trying to say is that it is unfair, right? It is unfair to the path. Basically in this path I'm adding more edge, and in this path I'm adding less weight. So hence this path got shorter now. So basically if you add or if you subtract, okay, if you add or you subtract, then I mean you can take this for the subtract, you can take this same example, okay, just assume this is the earlier situation, and now the shortest path is this, which means you assume this is 6, 6, 8. Okay, you subtract, let's suppose 5 from everywhere, okay, this is 6, 6, 8. Shortest path is this, right? This is earlier. Now you subtract. What is the shortest path? What do you need to subtract? Let's suppose you subtract 5 from everywhere, right? Now the shortest path became this, okay? Now this is shortest, right? This is now. So basically if you subtract or if you add, okay, this is -5, okay, -5. If you subtract or if you add, then it is unfair to the paths, right? If you add or if you subtract, then it is unfair to the path. So add and subtract can't work in the, I mean the shortest path may change, right? So that's why it can't work. What about the multiplication and division? These things will work, right? These things will work because whatever, if you divide, then it is basically not based on the length, which means earlier, let's suppose this is the shortest, right? Let's suppose this is the shortest, and this is having many edges. Doesn't matter. Actually, let's suppose this is having many edges, and if you add all of this, let's suppose all of these weights, W1 plus W2 plus W3, and now if you even divide it, then also basically the comparison is fair. So now you are comparing between this W1, W2, W3 upon C. Earlier you were comparing, let's suppose earlier you were comparing between W1 plus W2 plus W3, and let's suppose there is some weight which is W5 plus W6. Earlier you were saying that in between these two, this is maybe this is greater. Now you tell me in between these two which one is greater? Even if you divide or the subtract or divide or multiply, in between these two which is greater? W5 plus W6 divided by C. Again this is greater. If this is earlier, then now also this is the case, which means if earlier this was the greater, now after division also this was the greater, because this is a fair thing, right? I'm doing the same, I mean similar quantity. But if you add, then based on the how many are there, then the quantity will different. Here you will be adding 3C, here you will be adding 3C, here you are adding 2C. So that's why add or subtract will differ, but the division and multiplication will be same. Okay. So basically earlier if you have this, then later also the relation will same. Okay, I hope you understood that. Let's suppose this is W1 plus W2 plus W3. I am saying that this is W5 plus W6. Okay, I am saying that you add. Okay, suppose you add. Suppose you just forget about this question. You just tell me, suppose this is the case now. You add here, okay, you add here, let's suppose you add here 3C. You add here 3C, you add here 2C. Okay. Tell me, are you confident that this is the case now also? Are you confident about it? That this is the case now also? Okay, if you had different quantities, is this the case? Need not to be, right? This is earlier. If this path is, let's suppose, greater, or maybe this path is lesser, okay, in other words, this path is lesser, then now need not to be, it is lesser, right? This need not to be. Okay, this need not to be. But if you divide, okay, if you divide, let's suppose, by C, if you divide by C or multiply by C or whatever, if you divide the whole quantity with the same things, okay, with the same thing, then you tell me, is the comparison fair now? If you multiply by C here, if you multiply by C here also, now is the comparison fair? Yes, yes. Now we are confident, right? Now we are sure. Because you can definitely cut them, right? It is nothing like this, right? Okay, you can definitely cut them and then you can tell me, okay, now you are sure. So if you are adding 3C and 2C, because the addition, for the addition, this will depend on the length of the path. Now for the multiplication and these things, it will not depend on the length of the path, right? Okay. I hope you got it. Okay. Now let's see this question. This was also really a nice question. Okay. Now what this question is saying is really a good question. Let's just see this question. What this is saying, that you have some array. Okay. You have some array to start with, and then you are saying, for this particular array, which is 23, 22, 16, 11, 15, 3, 4 and 10. For this particular array, you apply some sorting algorithm, some unknown sorting algorithm, and then you have changed the array element orders. Okay, maybe the 22 you have not changed, maybe the 16 you have not changed, okay, maybe the 11 you have not changed, okay, maybe the 15 you have not changed, okay, maybe the 3 you have not changed, maybe 4 you have not changed, but 23 you have changed. Okay, anyway, I mean, you have changed some order. Okay, you have changed some order. This in between, seems like, okay, seems like in between this is same, but this is basically, you can say, this is this order got changed, right? Now what they're saying, which possible algorithm you might have applied? Tell me, would you have applied the insertion sort? What does the insertion sort says? Okay, this is in between stage. Okay, this is in between stage. Okay, this is in between you got it. See, first of all, tell me, was this a good question or not? Was this a good question? Tell me, was this a good question or not? If that was a good question, then just tell me. Okay, that, I mean, we have framed this question very carefully. That's why I'm just asking you, was this a good question? See, we have also mentioned that this is the usual top down recursive. I mean, it is not a bottom up. Do you know the merge sort is also the top down and bottom up? Do you know this? Top down, and it is also the bottom up. Right. So it was really a good question, as most of you are agreeing. Now let's just see that what they are trying to ask in this particular question. See, in the insertion sort, what happens, and can you get this kind of array in between of insertion sort? Tell me. See, in insertion sort, what happens? Insertion sort says, in insertion sort we say that you will say that, okay, you will I mean, say that if whatever is the array, right, whatever is the array, you will say that the invariant of the insertion sort is that you will keep on fitting it, right? Keep on fitting it in the left or right. I mean, it depends on you. You will keep on fitting it, right? Maybe to the left or right. So basically, you can say that this part is unaffected, right? This part is unaffected. This part is sorted, right? Isn't it? Tell me, aren't you doing this kind of thing in insertion sort? Isn't it the insertion sort thing? So is there any element which satisfy this property, that, okay, before this is sorted? See, I don't think that before 16 is okay, maybe before 16 is sorted, like after 16 it is not unaffected. Is this unaffected? No. So basically unaffected part is even not there. So no element is satisfying this property, right? So that is why insertion sort is not the case. I hope you understood that why insertion sort is not the case here. See, for the insertion sort, this part is sorted and one of the part is unaffected, right? Now there is like, if you keep like, I mean, this 23 is there, right? Because of this 23, you will say you will say that unaffected part is actually not applicable here. So hence you will say this is not the insertion sort, right? This is not the insertion sort. Okay. Now tell me, can it be the merge sort? Can it be the merge sort? What about the merge sort? This is interesting. Those who have watched the merge sort lecture at the Go classes, those people already know that it is not our merge sort. Why? See, the merge sort says that 1 to n, I mean array, okay, whatever the array, let's suppose the index is the 1 to n, then it will divide the array into two parts. It will say the merge sort or merge, whatever you want to call it, okay, merge sort, okay, it will divide it into two parts. It will say 1 to n by 2, and then it will say n by 2 plus 1 to n, isn't it? I mean, it will merge sort, so it will keep on dividing into two parts, once there is only one element, okay, then you will say that now let me merge it, okay, now let me merge it, isn't it do the same thing? So if you are calling the merge sort on any array, so basically it doesn't change anything, okay. I mean, these recursive calls, these calls are not, these are just calling, okay, it is calling this, so this call doesn't change anything. But as you know that what will happen, that you will divide it, okay, into two parts, so tell me if I just ask you, okay, if I just ask you one thing, okay, let's suppose this is merge, okay, let me just ask you quickly one thing, okay, merge sort array, okay, let me not write a again and again, let me just write it quickly, 1 to 8, okay, I mean this is a comma 1 to 8, but okay, doesn't matter. So this is, let's suppose 1 comma 4, this is, let's suppose 5 comma 8, this is suppose 1 comma, okay, I'm not writing from 0, just for your sake of understanding, I'm writing from 1, doesn't matter, okay. Just let me just explain quickly. 1 comma 2, I mean there are two elements, 1 and 2, let's suppose there are again two elements, 3 and 4, there are 5 6, and let's suppose 7 8, okay, again two elements, right? Now this will be 1 comma 1, let's suppose it is 2 comma 2, and then 3 comma 3, then 4 comma 4, and so on, right? 5 comma 5, 6 comma 6, and so on, 8 comma 8. Now whenever this merge sort is calling this merge sort, is this any doing sorting? No, it is doing sorting. No, till now there is no sorting. So basically it will keep on calling. See, this will call this, this will call this, this will call this, it will keep on calling. Let's suppose I ask you, let's suppose out of the context, let's suppose I ask you a random question, that suppose in the merge sort I ask you that suppose this call, it has called 2, I mean it will call this, and then in future it will call this, or do you think it is calling in parallel? It is calling this also, and two machines are running, or there is only one machine running. You just need to tell me there are two machines running or doing the both of the things, or it will call this first. The execution order is like this, right? It will call this first, and then once it is complete, then only it will call this, right? So basically what I'm trying to say here is that it will call this, and then once it is complete, okay, now tell me, suppose I say that this is complete, then what it will do? It will call this. If it is complete, then what does this mean? It means actually that initial 4 elements are actually sorted. 1 2 3 4, isn't it? The initial 4 elements are actually sorted. If you are having something like this, then it means that initial 4 elements are actually sorted, which means if you are saying that okay, it is already complete, I mean this particular call is complete, then initial 4 elements are already sorted, and the later 4 elements are yet to be sorted. So if this call is complete, then array will look like this: sorted and yet to be sorted, right? Okay, now you tell me if I just ask you, let's suppose only this is complete. See, let's suppose, interestingly, let's suppose I ask you, see, it will call this in the future. So whatever it is doing in the future, I'm just removing it, okay? Because that is a thing, that is something that it will do in the future, isn't it? Now suppose I say that see, this is the all tree I'm making, but suppose I say that okay, at some point in time it has called this, and then this has returned, and this is done. Once this is done, then tell me what is the next thing it will do? It will call this, right? Once this is done completely, I mean this sub programs are done, then it will call this. So now you tell me, once this is done, how the array will look like? Array will say that okay, initial 1 2 is sorted, right? These two elements are sorted, this is yet to be sorted. So isn't it same as insertion sort? I mean the way the internal elements are behaving in the same as insertion sort, isn't it? That it is sorted, this is unaffected, yet to be sorted, right? isn't it? Isn't the merge sort and the insertion sort internally, I mean the array, the way array is working, most probably, I mean they are almost same, isn't it? Almost, I'm not saying exactly, but I'm just trying to borrow the idea. So basically here once this call is complete, once this call is complete, I will say initial two elements are sorted, right? These two elements are sorted. Now once this call is also complete, I will say initial four elements are sorted. Once this call is complete, I will say okay, the four elements are sorted. Okay, actually this was not exactly insertion sort, but yeah, let me just tell you. See, once this is complete, I will say okay, two elements are sorted. Once this is complete, I will say next two elements are sorted, but it may be the case there is no relation between these two, right? It may be 3 5, this may be 1 4 or something, right? I mean there might not be any relation, but once this is complete, then I will say okay, now I will say this will be see, once this is also complete, right, I will say this will be something like this. This will be 1 3 4 5. I mean this particular whole thing is complete once this is complete. See, once this is complete, this is 3 5, I mean this is sorted. Once this is complete, this is 1 4, this is sorted. Once this is complete, then this is whole thing is complete, right? Okay, I don't have a I don't have a good diagram here. I mean currently with me, if you want I can just plug in the hard drive and I have the diagram there, but I hope it will take just 2-3 minutes. Do you want me to borrow the diagram? Just let me know, or we can just work directly. Okay, maybe let me just quickly borrow the diagram, right? Can you hear me? Okay, I think everything is good, right? Okay, so basically, I mean, this is from our slide, from the course slide. Let me not discuss the question. So basically, this is the internal states of the merge sort. That's what only I just want to quickly discuss, right? So which means that if you let's suppose have something like this, okay, if you let's suppose have something like this, okay, which is totally unordered, right, which is totally unordered, then in internally it might so happen that merge sort might have done, I mean till this point it might have done, then maybe some part of it has been basically this merge sort, let's suppose these are 8 elements, 1 to 8, then merge sort in first half maybe 1 to 4 is done, and then it will call two things, I mean it will call one more, which is basically merge sort 5 to 8, something like this. In between, here this is basically 5 to you can say 5, I mean this half part of this, okay, 5 to 6 and something like this, merge sort. Basically these three calls are done. This call is done, okay, this half part is done, this half part is done, only merging is remaining. It seems like only merging is remaining. Once this merging is also done, then this will also be sorted, and then once this merging is done, then this is also sorted. So if I just ask you, given this diagram, can you point out what has been done? This is completely done, this is completely done, this is completely done. Now if you remember, this is merge also, okay, this is merge also. It's called one more function which is merge, right? Okay, it will call one more function which is merge. So basically only merge is remaining. Okay, so basically it is sorted, it is also sorted, but this merge is remaining. Once this merge is done, then this whole merge is remaining, right? So that's how the merge sort will work. Anyway, so basically given any if I just ask you that array, what is the in between array for the merge sort, then you will say that, see, for the merge sort itself, you will say that, okay, that for this particular array, okay, that this may be sorted, right? I mean, we need to have something as sorted. So basically this 23 is here, right? 23 is here. It doesn't happen in the merge sort, at least, right? This 23 is here, it doesn't happen in the merge sort, right? So merge sort will say that, okay, I mean, some part of this is sorted, it doesn't seem like this is from the merge sort. So that's why merge sort is not the answer, right? Okay, now you tell me, can the quick sort be the answer? What about the quick sort? Quick sort says, see, the quick sort is one idea, okay? Quick sort is one idea. What does the quick sort says? It says that you pick a pivot, any pivot you pick, and now what is this arrangement? Okay, what about this arrangement? Actually, this arrangement is like this. This is same, but actually it doesn't matter. Which means quick sort says that whatever you have here, okay, whatever the initial array you have here, you pick some pivot. And after the call to that quick sort, okay, the one call to that quick sort, then what is the intermediate state? Let's suppose you pick this pivot, then 23 will be here. Before 23, everything lesser than or equal to 23, and here everything greater than or equal to 23. So basically what I'm trying to say, that it doesn't tell you the order here, okay? The idea doesn't tell you what is the order of this lesser than or equal to. Maybe the same order, maybe this is jumbled up. Okay, can this happen in the quick sort? Let's suppose if I ask you, is this a correct state in the quick sort? Okay, can some implementation of the quick sort have something like this? Can some implementation of quick sort have something like this? Tell me. This is 23, and maybe some random order, 11, 16, maybe 3, 11, 3, maybe 22, 4, and what is remaining? 11, 16, 15 is remaining, right? And then 1, 2, 3, 4, 5, 6. What other element is remaining? 16. Okay, is this possible from here to here? Is this possible in quick sort? What do you think? Quick sort. See, quick sort is the idea. The implementation is maybe different. It says that, okay, we pick the pivot. It will be, okay, wherever it is. Okay, left of the pivot will be lesser than equal to that, and this will be the greater than equal to that. What is the order of this lesser than equal to? It is not something which quick sort tell you. Okay, this is the idea. Now how you implement it, it will depend on that. Okay, what is the order of this? It will depend on how you implement it. But the idea says that, okay, you can have any order. Okay, it doesn't matter. Hope you understood. So basically, is this possible in the quick sort? Then answer is yes, because everything is lesser than this. So yeah, that is possible in the quick sort. What about the heap sort? So I think we have the options like quick sort, which is possible. What about the heap sort? Heap sort says what? Tell me, is this possible in the heap sort? Just tell me, what do you think? Is this thing possible in the heap sort also? Okay, let me know what do you think? In the heap sort also it is possible, right? So what does the heap sort says? Heap sort says that you keep, it will keep on extracting the maximum. Okay, it will keep on extracting the maximum. So whatever is the maximum, it will extract this maximum, put at the end of the array, right? Put at the end of the array. It will extract the maximum at the first, or the minimum, whatever you want to do, heap, min heap or max heap, and it will put at the end of it, right? And then it will pick the next maximum, which means 22. It will pick the put at the end of it. So like that. So heap sort and quick sort both are definitely possible, right? Okay, so quicksort, heap sort. Now let's just go to the next question because we have spent too much time here. Okay, this is really a very nice question. This is really a very nice question. How many of you were able to solve it? How many of you were able to solve it? It is saying that you want to find out largest, second largest, and the third largest element from the collection of 8 elements, right? Using comparisons. Okay, see, you have 8 elements here. Let's suppose this is the element 1. Okay, this is the element 2. This is the element 3. This is the element 4. And this is the element 5. This is the element 6. This is the element 7. And let's suppose this is the element this is the element 8, right? Let's suppose this is the element 8. Element 8. Okay, now they are saying here, okay, whatever the order of this, maybe 2, 1, 3, okay, doesn't matter. Okay, whatever is the order of this, maybe some order is this, then they are saying you compare. Okay, you compare, and using comparison we need to find the 3 numbers. We need to report 3 numbers. What are those 3 numbers? 6, 7, 8. Okay, I mean largest, second largest, and the third largest. You need to report 3 numbers. Now okay, curious gamer is asking, sir, if sorted means by default increasing or decreasing? It will be given in the question. Okay, it will be, generally they have increasing, but it will be given in the question. Don't worry about it. Okay, now let's just see, we need to find out largest, second largest, and the third largest. So what we can do, see here, there is a very interesting idea. What we can do, we can say, that these 2 elements we will be comparing. Okay, these 2 elements we will be comparing pairwise. So you compare this will be 8, this will be 5, this will be 7, this will be 6. Now you are saying you compare these two again. This will be 8, this, I mean 7 will be winner. And now you compare the 7 and 8. Who will be winner? Finally 8 will be winner, right? Okay, so that's how you find out the winner. So basically you can calculate it. I mean, there is if there are n elements, then you have to do n-1 comparisons. Okay, you have to do n-1 comparisons to find out the winner. Maybe if you want, you can even count it. See, this is 1 comparison, 2, 3, 4, right? Then 5, you are comparing these 2 elements, 5, 6, and 7 comparisons. So 7 comparisons or n-1 comparisons you have to do it to find out the winner. So using 7 comparisons, you can say that, okay, I have got my winner, right? So what is the winner here? 8 is the winner. And how many comparisons you have found out? So 7 comparisons, 4 largest. This is 4 largest. Okay, now let's just see for the second largest how many you will be doing. Right? For the second largest, how many comparisons you will be doing? See, the second largest, let's suppose there are people. Okay, let's suppose there are people in the ground. Okay, and let's suppose this is the most bodybuilder. I mean, this is, let's suppose there is some person who is really a very good bodybuilder. Let's suppose this is very, very powerful. Okay, powerful, which means it is the highest. Now obviously it will be the winner. If you have the matches, it will be the winner, right? Which is 8 is the winner. Okay, 8 is the winner. Now let's suppose this is the second highest. Okay, second highest. And if you have the matches, then who can defeat the 7? See, who can defeat the 7? Who can defeat this 7? Can this 3 defeat the 7? 3, 7, no. Can this 6 defeat the 7? No. Only 8 can defeat, right? Maybe initially 7 might be here, okay, and 2 might be here. I'm not saying that 7 will be here only. 7 might be here, 2 might be here. So basically what I'm trying to say, that the 7 has to get defeated by 8 only. So basically if you want to find out the second highest, one thing is you are for sure that the second highest must have been defeated by 8. So maybe this is the second highest. I mean, you don't know, right? Maybe this is the second highest, or maybe this is the second highest, which means whoever got compared with 8, there's only these 3 elements are the second highest. I mean, the second highest must be among these 3, right? Either this or this or this. So second highest, you will say, must be among these 3. So for these three, I mean, among these three, you need to pick the highest. I mean, that will be the second highest. So there will be 3 minus 1, which is 2 comparisons. So using 2 more comparisons, basically you will be getting the second highest, right? So I'm not spending more time here, but I hope you understood. 2 more comparisons for the second highest, because the second highest will be among these three. Whoever 8 has defeated, 8 has defeated this, and who is 8 has defeated which element, this, and 8 has defeated this. So among these three only the second highest will be lying. So that's why these three 2 comparisons, because 3 minus 1, right, for second highest. Okay, now interestingly, for third highest, how much you will be doing? See, the third highest either got defeated by 8 or by 7 maybe, right? So the third highest either got defeated by 8 or maybe third highest got defeated by 7. And we know that 8, so for 8, how many elements are there that 8 is fighting for? 8 has fought with 3 elements, right? 8 has fought with 3 elements. But out of these 3 elements, I know that one of them is second highest. So that is why only 2 is the candidate for the third highest. These are the 2 candidates for the third highest from the 8, and 7 has fought these 2. So these 2 are the candidate for the third highest using 7. So here total 4 candidates are there for the third highest. Are you getting why? Because see, third highest is either defeated by 7 or defeated by 8. Okay, I mean, the 6 could have been here, though it is in the first round itself, it is defeated by 8. So anyway, the third highest either defeated by 7 or defeated by 8. So how many elements are defeated by 7? These 2, right? How many elements are defeated by 8? These 3, but out of these 3, we know one of them is 7, right? One of them is the highest. So that is why these 2 only, you will take care of these 2. So these 4 are the candidates of the third highest. So 4 minus 1, which is 3 comparisons you need to do for the third highest. I mean, this is just one of the algorithm, right? So plus 3 for the third highest. So this is total 12 you need, right? This is just one of the algorithm I have suggested. Okay, so you see here, total 12 you need. Okay, 12 comparisons to find out the first highest, the second highest, and the third highest. Okay, so initially 8 candidates, and now there are 3 candidates. Okay, because these 3 are the candidates, and now again there are 2 candidates. Okay, there are 4 candidates, which means these 4 are the candidates. This one, this one, this one, this one. Not including this 7. Okay, not including the 7. Okay, so these 4 are the candidates for the third highest. So that's why 4 minus 1, 3. So which is 12. So in 12 comparisons you can do it. Now let's just read the options. They are saying all comparison based algorithm. They are not saying sorting algorithm. It is not sorting algorithm. Okay, this is not sorting algorithm. They are just saying all comparison based algorithm required n log n or 8 log 8 for 24 comparisons. No, we have just got the algorithm which is comparison based only, that can do the job in 12. Okay, 12 comparisons, that can do the job in 12 comparisons. Maybe some better algorithm is there, maybe that can just do the job in maybe 11 comparisons, or I don't know, but 12 comparisons we have got, right? There are just a comparison based algorithm that accomplishes the task in 12 comparisons or fewer. Okay, or fewer maybe. Okay, yes, so there is one algorithm that is 12, at least 12 we have got, right? There is a comparison algorithm that accomplishes a task in 8 comparisons or fewer. See, in the 7 you need, in the 7 you will be needing for the highest, for the first, and just one more. They are saying just one more for the second and third. No, right? Just one more for the second and third. It is not possible. So in the 8, it is not possible. In the 24, you don't need 24. You don't need 24, right? Minimum 24, no. Minimum 24, no. You don't need 24. No comparison-based algorithm can identify all 3 elements in lesser than 16 comparisons. No, we have just got one algorithm that can do in 12 comparisons. So that's also wrong, right? This is wrong. This is wrong. So hence, C is the correct answer. Right? C is the correct answer. Okay. So Shreyas is asking, sir, can we do index based counting sorter, these things? No, they are asking about the comparisons. Okay, using comparisons. Question is about the comparisons. Okay, and the counting sort, radix sort, these kind of sortings require some assumptions, if you remember, and the question is about the comparisons itself. Okay, now let's see this question. This question was also nice. So how many of you were able to solve this particular question? This was really a very, very good question. How many of you were able to solve this particular question? See, this question is saying This question was very very nice. This question is saying, this question is actually testing your combinatorics skills, right? Very nice question, just testing your combinatorics skills. So this question is saying that you have n sided die, okay, n sided, sorry, not n sided, n dice which are four sided, okay, which are four sided. Now what they're saying, let's suppose you have maybe 10 dices, okay, or maybe let's suppose you have two dices, okay, or maybe whatever number of the dices you have, let's suppose you have two dices, okay, which are four sided, okay. Now they're saying that if the dice is just one, n means number of dices, if it is one and you want the summation is m, okay, you want the summation to be m, and then it is negative, this is negative or greater than 4, obviously it is not possible. That's why the zero ways, in zero ways you can get this summation which is negative or greater than 4. Obviously you can't get like, okay, so less than equal to 0 or greater than 4. So what is this m here? Okay, so four sided dice to get the summation of 4, so as indicated below. Now if it's just one dice, if it is just one dice and you want a summation between 1 to 4, then what does this mean? If it's just one dice, then just if it is just one dice, then you can do in just one way. If it is just one dice and you want the negative summation, see, using just one dice, can you get negative summation, or can you get more than 4 also using just one dice? So no, right? Using just one dice, you can get between 1 to 4 in just one way, right? In just one way. Okay, I mean, you will place the dice. Let's suppose you want m equal to 2. M equal to 2. So you will say that, okay, on top of the dice, there will be 2. If you want m equal to 4, on the top of that, there's just one way, right? There's just one way, right? Okay. Now what they're saying, that if you have in general, you may be having n dices and you want the summation to be m. Now what you will do, you will say, okay, let's suppose I have n dices here, okay, 1, 2, 3, like this, right? So there are, let's suppose, n dices. Now let's just do one thing. Do you remember one LCS problem? Do you remember what we do? Let's suppose x1, x2, xn, y1, y2, ym. We say that, okay, we will start from the end, we will not take this, we will compare between these two and so on, right? Something like this. I mean, many of the diagonal programming algorithms are like this, either start from the first or start from the end, or something like this, right? Okay, so now what I'm trying to say here is that, let's suppose this is the end. I mean, this is basically you have n dices. This is the last dice, okay, this is the last dice. You want the summation to be m. So maybe this is one way, okay, maybe this is one way, or maybe there are many ways. So what I can do it recursively, I can say, let me just skip this, okay, let me just skip this dices. These are how many dices? n minus 1 dices. So using this n minus 1 dices, okay, can I produce m? See, the m is not useful because here you can't get 0, because using the n dices you need m, right? So using this n minus 1 dices, you will ask, can I produce m minus 1? Can I produce n minus 2? Can I produce n minus 3? Can I produce n minus 4? Let's suppose there are n dices, okay, n dices, and there are, let's suppose these are the n minus 1 dices. Using these n minus 1 dices, there are maybe, let's suppose 2 ways to produce m minus 1, sum as m minus 1, 3 ways to produce sum as m minus 2, okay, and so on. And maybe let's suppose there are like this, okay, there are, let's suppose 5 ways to produce sum as m minus 1. There are, let's suppose, 2 ways to produce sum as m minus 2, 3 ways to produce sum as m minus 3. There are, let's suppose, 1 way, okay, to produce, or maybe 2 ways to produce sum as m minus 4, or whatever, right? Which means using this n minus 1, if I can produce in 5 by m minus 1, summation, if I can get, okay, let's just not worry about any other summation. If I can just get m minus 1, then you tell me in how many ways I can get m. See, using this n minus 1 dices, if in 5 ways I can get m minus 1, then just here what number we will be needing? Just one, right? We will be needing one, isn't it? We will be needing one. So basically, if if this is the 5 ways in which you can produce m minus 1, and this is the one way, right? One way. It is always one way actually. It is always one way. The last dice is always one way. In one way you can produce what is the remaining. This is m minus 1. The remaining is 1, right? You can produce 1. Then total how many ways you can produce m minus 1? Let's suppose. Then you will say you will multiply this, right? 5. I mean 5 into this is always 1 actually. This is always 1. Okay. So this is just 5 ways. In 5 ways you can produce m. But let's suppose I say in 5 ways you can produce m minus 1. In 2 ways you can produce m minus 2. So 5 ways m minus 1. And then for this 5 ways there is one way to produce 1. For these 2 ways there is one way to produce 2, because this is m minus 2. For this 3 ways there is one way to produce 3. For this 4 ways, this 2 ways, there is one way to produce, this is m minus 1, 2, 3. Okay, this will go till 3 only, right? Sorry, it will start from 0. Let me just check it. I think. Yeah, anyway, this will be 0. Even if you write it, this number will be 0, I think, right? No, sorry, that is fine. So here, if you are having m minus 4, then you can have 4 here, so that the summation is m basically, right? So what you will say that, okay, whatever number of ways here, 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 right? And multiplied by 1. So basically whatever is the number of ways using n minus 1, you can get m minus 1, m minus 2, m minus 3, m minus 4. Okay, I mean using n minus 1, okay, using n minus 1 and multiply by 1. So that's why A is the answer here. C is not the correct answer. It is not addition of 1. Okay, it is not addition of 1. Okay, some people might have done C, but it is not the correct answer. Okay, now A is the correct answer here. Now let's just go to this question. How many of you were able to solve this question? Tell me. How many of you were able to solve this question? What this question is saying, that you have I think how many threads you have? You have 2 processes or 2 threads, right? So basically this is saying you go to sleep for 3 milliseconds and you compute for 2 milliseconds, right? It is also, I think, a doable question. It's not very tough. So what you do? You compute for 2 milliseconds. So this is computing for 2 milliseconds. And then you go to sleep for 3 milliseconds, right? This is 3 milliseconds you go to sleep. Now what they're saying is that this is thread 1. Once you are going to sleep, at that time for 2 milliseconds other thread will be running, right? The other thread or the other process will be running. And then this is 2 milliseconds. And then it will go to sleep again for 3 milliseconds, right? So this is 3 milliseconds. Okay. So anyway, now at this point in time, this particular thread will be running again for 2 milliseconds. So basically this is 5, I think. Okay, yeah, so this will get over. This is 2 and 3, and this is 3. Once this 3 is over, and this will be 2, right? Okay, so what is happening here, that you start with this, you will say that, okay, this is running 2 milliseconds, and then it will go to the sleep for 3 milliseconds, right? And that's what you have to do 10 times. So basically if you do this 10 times, right, then you observe here one thing is that this is 5 milliseconds. Then you will be keep, I mean if you want to start again, you can definitely start. You are not blocking again. So basically 50 milliseconds anyway you will take. 50 milliseconds just for this thread. Okay, in parallel other thread is running, that's okay. In parallel other thread is running, but once this thread will be finished, see, for every finish of this, you tell me how much extra the other thread is running. See here, that once this thread will get finished, I mean, let's suppose the one iteration is getting finished. Now this has to run 3 milliseconds, right? So there are 1 millisecond it has already taken. Okay, because this is total 3 millisecond. You might have seen this particular window. This total is 3 millisecond. 2 milliseconds is here. 1 millisecond is already taken. And now there will be 2 more milliseconds, right? 2 more milliseconds. So what I'm saying, that once any iteration of this is end, then 2 more milliseconds the other thread has to run. I mean, this for loop, it is sleeping, computing, doesn't matter, but 2 milliseconds more. So after 50 milliseconds this thread will be over, but 2 more milliseconds this particular thread the next thread will be sleeping. So total time by which both threads will get completed is 52, right? Yes, yes. So every one of you have given the correct answer. Okay, great. Now let's just see this question. How many of you were able to solve or were not able to solve this question? So here what they are saying, let's just see. Here what they are saying is that given this they are saying that which of this will get printed. Can you print? See here, this random can generate 0. It can also generate 0 and 1, 2, 3 like this. Okay. Can you print ABC, ABCD, ABCD? Okay. Can you print ABCD, ABCD and then AB? See, A is possible. After that is B possible. Yes, maybe you have executed this. Okay, initially the semaphore value is 0. See, the A is possible how? I mean, ABCD is possible how? Maybe you have executed this, and maybe the random variable was 1, and then you have executed this, and then you have executed this, and then you have executed the C, right? And then D. So basically, definitely ABCD is possible. How? Maybe the random variable is 1, and then you print A, then you execute this, then you execute this, then you execute this, then you execute this, right? So basically this is maybe 1, this is 2, this is 3, this is 4, step number 4, this is step number 5. So using this ABCD is possible, right? Using this ABCD is definitely possible. A, B, B, and then I mean you execute this is step number 2, then B, C, D, and you will keep on repeating. So ABCD again and again possible. Yes. So ABCD again and again possible if n is 1 and the execution is this. Is ABD, BD, is this possible? A and then BD, yes, it is possible after executing this obviously. And then BD again and again. And at last they are saying A. Okay, at last they are saying A. See, the difference between this option and this option is that at last they are saying A and they are saying C. Okay, that's the only difference. See here, A and then BD, yes, you have to execute this, and then BD like this, and then you have to come back, right? You have to come back. So C is possible, but you can't just directly go this. So that's why A is not possible, and then C at the end is possible, right? So this is possible. What about this D? BCD, and A. So is this possible? Tell me, is this possible to get BCD? See, maybe n is 0. At that time, what will happen? Then you will say you will execute this, then B, and then this, right? Then B, C, and then D. And then again n is 0, and then again B, C, D is possible, right? So BCD like this is possible if n is 0 again and again, right? So this is definitely possible. This is also possible, right? This BCD is possible if n is 0, because this n can be 0. That is what given in this question. Okay. Now let's see this question. This question is from computer networks, and what they are saying that how many IP interface are reachable from interface 0. Okay, from this interface how many IP addresses are reachable? See, if the IP address is starting from 1, then they are saying you go here, but it will go to the longest one, right? If it is starting from 10, how many are reachable here? See, this is just 8-bit long, so which means 6 bits are remaining. 2 power 6 are reachable here, which is 64 are reachable here. How many are reachable from here? 2 power 5, which is 32 are reachable here. So they are asking that how many are reachable from 1? How many are reachable from 1? See, ideally 2 power 7 is reachable, but out of this 2 power 7, you can say that this 64 plus 32, or maybe this these two. I mean, if it is matching either this or this, okay, it will go this, right? So you will say the 96 are basically taking over these two. So which means 128 minus 96, which is how much? 32. 32 are reachable, right? Okay. Okay. So some people are saying how C is possible. In the earlier question, ABD, how C is possible, because you can do, see, C is saying ABD, BD. Okay, So let's just see this. See, C is saying A, B, D, B, D, B, D, B, D, and C. See, A is possible if N is 1 and B, D, right? After executing this, then B, D, and then again B, D, see A and then B, D, and then they are saying B, D. Is this possible? See, after this A, yeah, see what is happening. A is completed, then you execute this, then BD is possible, right? And then maybe I can just copy this again. See, why you are asking about the C, right? Okay. See, this A, BD, 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 and C. Okay. This A is possible, right? After A, maybe you execute this, and then you go to this, right? Then you can execute BD, BD any number of times, right? You can execute BB. This, if P is there, then V is also there, right? You can execute BD, BD. So you execute this A. After this, any number of times BD is possible. Okay. So print A and then this. So basically, then V of SB. Okay. You print A, then V of SB. Okay. From right A. From right A you do this. Okay. From right A, okay, you do this. You print A. Okay. You print A, print FA, and then this. So you print A, and then this, right? And then you go here, and you keep on doing BD, BD, BD any number of times. BD, 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 BD. And at the last, you come here and then you print C. Isn't it? Okay. This is SB, not SA. Okay. Got it. So here, okay, got it. This is SA and this is SB. Okay. Let me just go to the next page. So you are saying, okay. So both of the semaphores are initialized to 0. Now you print A, and then since it is SB, okay, so you may be printing C, or you may not be printing C, but you execute this. Now it is saying the P of SB. So you can print BD, but okay, sorry, you can't print B. Yeah, you can print BD. And now you definitely need again you definitely need this V, right? You again definitely need this V, because this is SA. So you may be incrementing it, and I don't think it will help you in anyhow, right? This SA won't help you anyhow. So maybe you can just ignore this SA, right? Because this SA is not putting any constraint. Okay, let me just ignore this SA. Okay. So this is like what you will do. You will say that, okay, for this to execute, you need to execute once this, right? You need to execute once this. So maybe you print A and then you execute this, right? Then you can execute this BD. But to again execute this BD, you have to again come back and then you have to print C, right? Yeah. So BD two times are not possible. Okay. I got it. Yeah, C is also not possible. Yes, C is also not possible. What about this A? Is this A possible? What is A saying? A, B, C. A, and then you go here, B, C, and then D. A, B, and then C, and then D, and then again A. Yeah, this is possible. Because again A and then B, because of this, right? This is possible. C is not possible. Okay, great. So C is not possible. I think in the answer I have given C. I will change the answer. Okay, I will change the answer. So C is also not possible. And what about this BCD? What about this? BCD? And what is the option D? BCD, and A. Is this possible? Let's just check. BCD, right? So BCD means that you will be printing this, and then B, and then CD. Okay, maybe I can go to the next page here. So tell me, is this BCD A possible? Okay, this is BCD B, C, D, A. Is this possible? You go here, this B, I mean, that is possible or not possible. Let's just see. You will increment this and then this B, right? This B. Okay, this B. Then this is B. And then is this C possible? B, you will be printing B. If n is equal to 0, then you don't print A, you directly go here, and then you print B, and then you print C, and then you print D, right? I think this BCD, initial BCD is possible. And then is this BCD possible again? Okay. And then if n is 0, then you will increment this. And then I think this B and then C and then D is possible, right? Okay. Okay. So I think this is possible. For n equal to 0, this is possible. And at the last, you can have a equal to 1. Okay. So A is possible, and also I think D is possible. Okay. So C is not possible. A and D are possible. Okay. So A and D are possible. Cool. Okay. So A and D are possible here, right? Great. Now let's just go to this question. Is this question understood to everyone? I hope this question is okay, right? Now let's just see this question, which is most interesting and most conceptual question, I can say, from the computer networks, or from at least from my subjects. So this is the most conceptual question from my subjects. See, what they're asking is that you tell me in TCP, you tell me in slow start what happens. Okay, in slow start what happens? In congestion avoidance phase. Okay. In congestion avoidance phase, what happens? In slow start, you increment the congestion window size. If you remember how much you increment, you say you double it, right? You say to double it. Okay. So basically you say that on each RTT, just listen me carefully, that what I'm writing here. On each RTT, what happens? Okay. On each RTT I'm saying, each RTT. On each RTT, you say you double it, or maybe one way of saying it, you just write like this, right? One way of saying it this is on each RTT. But can you tell me on each ACK what happens? If you recall, on each ACK what happens? This is on each RTT, but can you tell me on each ACK in the slow start what happens? You will say that you don't increment by, I mean, you don't double it. You will say you will increment it 1, right? I mean, if it is the unit, if the unit here is that MSS is a unit, if you remember, then we do plus equal to 1. Okay, plus equal to 1. Do you remember this? On each ACK? If you have heard about it, and also there are gate PYQs. Okay, there are gate PYQs regarding this. Do you know about it? There are gate PYQs, right? Or in other words, you increment by the MSS. If the unit is bytes, it depends on the unit actually, right? If the unit is MSS, if you are measuring in the multiple of MSS, you increment by 1. If you're measuring in terms of bytes, then you're incrementing by plus equal to MSS. You're measuring in terms of bytes. So here what is the unit? Unit is again in terms of, you can say, MSS, in MSS. In, like, generally we have in MSS only, like everything is in MSS. So basically you say you write like this. Okay, you plus equal to 1 or plus equal to CWND. The unit is MSS. Okay, unit is important here, that the congestion window unit is MSS, right? Okay, I hope that is fine. Now, and there are many gate PYQs also. Maybe I can just plug in just a while. I can just search the gate PYQ which are related to this concept only. Okay, on each RTT what is happening, on each ACK what is happening. Many of the aspirants doesn't understand this. Okay, then on each RTT what happens, on each ACK what happens. Now this is in the MSS, which means that you this is, let's suppose this is 5, then you will make it 10 MSS. Okay, 10 MSS. If this is 5, you will make it 6 MSS, like this. Okay, the unit is MSS. Now, if I just ask you here, okay, can you tell me in congestion avoidance phase what happens on each RTT? If you recall on each RTT, in each RTT we increment by 1. Okay, on each RTT we increment by 1, plus equal to 1. Okay, currently I don't have the Forojan screenshot, but I will, I might have it later. I will put in the slides. Okay, the Frozen screenshot I will put in the slides and I upload it. So on the Frozen also you can see in the book. Then on each RTT in congestion avoidance phase we do this, which means if it is 5 MSS, Then in each RTT, we do it like, for example, 6 MSS like this, right? Here on each ACK, how much we do, that is the question that they're asking actually. Okay, and that too in terms of bytes. Everything is in the bytes. Okay, now how much you increment on each ACK? See, this is the question, and that too in the unit is byte. Every unit is byte here. Okay, not MSS. You see that they are given that this is CW2ND bytes. Okay, like this, right? So now now let me just tell you. See, the question is that in congestion avoidance phase, on each ACK what you do, not on each RTD. Let's suppose that congestion window size is, let's suppose 100 bytes. Okay, maximum segment size is, let's suppose 10 bytes. Now you tell me on RTT how much you will increment. You will make it how much? What is the CWND, new CWND? 100 plus 10, isn't it? 110, right? 110 bytes. That's what they're asking. Okay, that how much you are incrementing, not on each RTT. Basically, they're asking in each ACK. Anyway, so basically, this is how you do in each RTT. These many bytes. Now the similar question on each ACK. What you do? Okay, how much you need to increment in each ACK? 100 plus how much? Can anyone tell me? 100 plus how much on each ACK? See here you will be incrementing. You will be incrementing by 10, right? By 10. If you get on each RTD, what does this mean of saying each RTD? It means if you get 100 bytes, okay? If you get 100 bytes of what we say, acknowledgement, right? I mean, if you get all of this acknowledgement, right, on each RTT, means that you whatever you are sending, you get ACK of all of this. Okay, here in the TCP terminology, we are calling it RTT. Okay, so on each 100 bytes, we are incrementing by 10. Now see, on each RTT means you are sending 100 bytes. Let's suppose you are sending 10 packets, and on each these are, let's suppose, 100 bytes total combinedly. Then whenever all of this 100 is received, all of this 100 ACKs are received for all of this, then you are incrementing how much? In congestion avoidance, you are incrementing by 100 plus 10 only, right? 10 only. Okay, whenever the 100 bytes of ACK is received, I'm just asking you, whenever just one ACK is of how much bytes? If MSS is of 10 bytes, then one ACK is of how much bytes? 10 bytes only. So the question is just this only. If 100 bytes of ACK received, which is same as saying RTT, okay, received, which is same as saying that RTT, okay. So which means on RTT, we are incrementing by, increment is, how much is the increment? 1 MSS, right? Increment is how much? 1 MSS. 1 MSS means 10 bytes. So increment is basically, here you can say it is 10 bytes, isn't it? If 100 bytes of ACK is received, which means you send 100 bytes, all of them is received, and then you increment just 10 bytes. I'm just asking you, on one ACK how much you are incrementing. So 100 bytes you received, you increment 10 bytes. Now on 10 bytes of ACK, 10 bytes whenever you receive, which means one packet or one ACK you received, how much you will be incrementing? 10 upon 100 into 10, isn't it? You will be incrementing this, right? So which means if I just ask you that, let's suppose this is in the bytes, CNW bytes, okay, of data you send, your complete window you send, then you increment how many? 1 MSS, which means MSS bytes, because they have given that MSS bytes are there in the maximum segment size. These are the MSS bytes. Okay, so if you send CWN2 bytes, then you receive MSS bytes. I mean, you increment by, this is the increment, you increment by MSS bytes. But if you received MSS bytes of ACK, okay, then how much you need to increment? See, if the whole window is received, which means CWND bytes is received, you increment 1 MSS or MSS bytes, then how much you receive? How much you increment? MSS upon CWND into MSS, isn't it? Into one more MSS. So MSS square upon CWND. This much you need to increment. Let me just ask you whether you have understood this or not. MSS square. Okay, tell me Have you understood this little bit maybe? Okay, maybe you can just answer me if you have understood this little bit. Okay, see, maybe I can just put some screenshot to you. Okay, you can see in the Wikipedia, and there are many resources to see this. That is how you need to increment basically, right? Okay. Let me just give me a second. Let me just you know plug in some screenshot. MSS into MSS divided by CWND. Yeah. See, what I'm saying here is that let me just first let me just put the screenshot. Actually, there are many resources. I'm just putting the screenshot of Wikipedia just to make sure that you are trusting me. Okay, you're trusting me on this. So this is a normal concept, but since it is not being taught in many coaching, so that's why like students doesn't know it much. If you see here, this MSS into MSS divided by CWND, okay, it increases this in the congestion avoidance phase. Okay, and see here what they are saying. This is a common formula that in on each new ACK, okay, in congestion avoidance phase, okay, then that is how it increments. Okay, and it is a common formula on on each new ACK how much is increment happening, and this is also the common formula. That's what they are saying, right? This is common. Anyway, so MSS into MSS upon CWND, and this is from Wikipedia, right? Yes, so Nandini Mishra is saying that I took a full lecture. Yes, so just one lecture I have spent, okay, to make sure that everyone understood this particular concept. Actually, this particular concept has been asked in GATE also. Let me just tell you in GATE also, okay. In GATE, I don't remember the year. Can anyone tell me if you are a goclasses student, which question was that? They have asked multiple question actually. Let me just a second. Yeah, this is one of the question. You just solve this, okay? That what is happening on each ACK. You just solve this question. This question has been asked in GATE 2004. You just solve this question. There has been recent question that has also been asked, okay, in GATE. Let me just put that also. Let me just put that also. I think in GATE 2021 or somewhere it has been asked. Yeah, in 18 you just solve these two questions, okay. Before solving this particular question, you solve this question, okay, this question and this GATE 2018 question, okay. You just solve these two questions before solving this question maybe, okay. So basically the idea here is to understand this table completely, okay. You need to understand this table completely, which means on each RTT what happens, on each ACK what happens, okay. On each RTT or what in terms of unit what is happening, or on each ACK what is happening. So basically you need to understand this fully, right? And that's what I'm saying. On RTT means CWND bytes. In CWND bytes you are incrementing by MSS bytes, right? You are incrementing by MSS bytes, okay. You're incrementing by MSS bytes, so increment is here MSS bytes, so which means on each RTT you are doing one increment, so one MSS, which is MSS bytes. On one ACK means one ACK same as saying MSS bytes of ACK, okay. One ACK same as saying MSS bytes. So how much you will increment? You will increment this much, right? So that is the answer. That is the answer, okay. So MSS into MSS divided by CWND, okay. See here in this question also they are asking, assume that no packet loss. What is the transmission? Okay, so basically they're asking the congestion window.
On each ACK, what is happening? See, they are asking on each ACK, on two ACKs, what is happening? On two ACKs, what is happening? On each ACK, basically, they are saying slow start each ACK. Basically, in this table, this is GATE 2004 question. So slow start, congestion avoidance. You need to understand what happens on each RTT. Okay, on each RTT. What happens on each ACK? In currently, I have asked this. Okay, AIMT has asked this. GATE 2004 has asked this. GATE 2004. Sorry, on each ACK they have asked, right? So GATE 2004 has asked this. GATE PYQ was related to this. You can solve the PYQ. We have asked related to this. And in 2008, in 18. Okay, this was 2004. This is in 2018. They're asking to on successful acknowledgement. Okay, on acknowledgement they're asking. This is regarding slow start phase. Okay, they ask slow start, and on each ACK, on each successful ACK, what is happening? On each RTT, what is happening? So basically, 2018 they've asked this. So 2018 you can say they have covered this. Okay, this was 2018. So GATE 2018 this and this. So GATE 2018 has asked these two things. We have asked this. Okay, we have asked this. Anyway. Now I hope you understood. So what is happening here? Okay, this was really a good question. I will suggest you to do it once more. Okay. Now let's solve this. Were you able to solve this question? Let me know. See, they are saying this particular question, by the way, from Ullman. Okay, from Ullman, directly from Ullman. They are saying that will not be recognized. Okay, see, there is a lecture of recursive descent parsing. I think the lecture name is 20 questions on recursive descent parsing on goclasses channel. Okay, on goclasses YouTube channel, there is a lecture named 20 questions on recursive descent parsing. I have solved that question there. Okay, you just solve it. It will only parse A. It will not be parsing all of this. Okay, it will not be parsing all of this. It will only parse A. There is a question. There is a lecture which is called 20 questions on recursive descent parsing. Okay, so you can search on the YouTube channel. Let me just do it for you. Okay, let me just do it for you, and let me just plug in that. Okay, so you can watch this lecture. We have already solved this particular question there. Okay, this is a very nice lecture, by the way. Okay, this is very nice lecture. So if you want to solve this question, this is easy question only. Once you understand the recursive descent parsing, you can definitely solve. So just search 20 questions on recursive descent parsing, something like this. Okay, so you will be able to solve this question directly, right? Cool. Yeah, how many of you were able to solve this? So here, if you observe, this V is eigenvector of both A and B. Okay, eigenvector of A and B. See, whenever there is a higher powers, right? Whenever there are higher powers, generally it must be the eigenvector. So if they are saying something like this and they're asking this value. By the way, do you like the question framing? Let's meet the main characters and these things. Okay, they are giving the New Year party and these kind of things, right? You might have liked it. Okay, so now let's just go to the next slide, and what I'm trying to say is this. See, here this A is an eigenvector. You can solve it with value. V is eigenvector with eigenvalue 2, and this V is eigenvector for another matrix with eigenvalue 1/2. Okay, 1/2. Okay, it is eigenvector of 0.5. Now, if you multiply, let me just first multiply B power 2023 into B. Okay, this will be same as B into B 2023 times into B, right? Now this B into B, just one time B into B will be 1/2 into B. Now this 1/2 you can take here, and now it will be again V into B. This will be again 1/2 V into B. So it will be 1/2 power 2023 times B. Right? Now basically they're asking you, yeah, C is the answer here. They're asking you This is same as 1 by 2 power 2023 v, and now you need to multiply in this you need to multiply how much? You need to multiply a power 2024. So here a power 2024, you need to multiply to 1 by 2 power 2023 into v, which is same as a power 2024. Okay, you can take this 1 by 2 2023 outside, because it's a scalar. You can put a scalar anywhere. You can put in between, you can put here, you can put here, you can put a scalar anywhere. Okay, this is a scalar, this is into v. Now again, if you do this will be 1 by 2 in power 2023 into 2 into 2024. So from here it will be just 2. Okay, so basically I mean 2 into v. So basically it is just 2 into v. So hence C is the answer here. Hence C is the answer. Okay, great. Now I hope you were able to solve this question. This was easy question only. You must be able to solve this question. You can use a tree method. Okay, you can use a tree method, or maybe you can directly say that probability of y being 1 is nothing but probability of y being 1 given that x equal to 0 into probability of x equal to 0 plus probability of y being 1 given that x equal to 1 into probability of x equal to 1, right? So from here, if you solve this, you will be getting 0.5 as answer. Okay, you just use this formula, or maybe tree method. Okay, or maybe tree method. Do you know the tree method? We have solved many questions using tree method. I think there's a YouTube video also on goclasses channel. Okay, just search the probability video. Okay, in one of the probability video, I've told the tree method, which is very nice, right? Okay. Okay. Now, was this question approachable? This question is also easy. They are saying that there is my array. Okay, my array is one array which is having 1, 5, 10 and 15. Now, there is another array, an array or something, which is pointing like this. This element is pointing 0, 1, 2 here. Okay, this element is pointing here. Okay, this is array of pointers. Okay, this is array of pointers, which is an array of pointers. Now, P is something which is pointing to my, so P is one, you can say one pointer which is pointing here, right? P is one pointer. PP, which is a pointer to a pointer, it is pointing to the first element here, right? It is pointing here. Okay, so this is the diagram. Once you make the diagram, you can solve easily. Now they are saying star P, which means this value they are incrementing to 2. That will get incremented in next line, but that's okay. I mean, this will get incremented to 2. Okay. Now PP plus plus, which means this PP, whatever PP is pointing to, PP plus plus means they are saying that now PP is pointing to this, which means this PP doesn't point to this anymore. Okay, PP doesn't point to this anymore, and PP points to this only, right? Now star PP, which means star PP means this 2. So 2 should be printed, right? 2 should be printed. Okay, so 2 is the answer here. See, I'm not telling you in very great detail because it is easy question. So if you are confused that why this PP is a double pointer, even though it is a pointing to array of element, but it is a double pointer because it is pointing to, actually you don't need to know that why it is a double pointer or not. It is a job of the programmer or job of the question maker. But it is a double pointer if it is pointing to something which is also pointing to something. See, with respect to this PP, it is pointing to one element of something which is pointing to the integer or something, right? So basically with respect to this PP, this is not the array. Okay, it might be pointing to the element of the array, but this is it is pointing to just a pointer. Okay, it is pointing to just a pointer which is pointing to something. So with respect to PP, it might be the part of the array. That's okay. It might be the part of the array, but it is pointing to something which is pointing to the pointer. We have talked about these things in a detail, okay, already in the classes. Okay. Now, were you able to solve this question? This was also a nice question, but easy one, right? I mean, not a very tough question, I think. So were you able to solve? Let me know how many of you were able to solve. So here they are just saying that how much is the memory leak happening. See here that if you call this particular function, right? If you call this particular function, then what is happening? Let me just try solving it. See. Here you are calling this G1, right? You are calling this G1. First you call G1, so there will be this is, let's suppose, the activation record of G1. Okay, this is G1. So there will be some ANS, right, which will be pointing to 4 bytes in heap. Okay, 4 bytes in heap, right? And then you're calling this mystery, which is Z comma ANS. So Z is initially, I think Z is 1. So it will return 0 basically. So now it is returning 0. So OK 0. So here OK 0 because it will return 0, right? So OK is 0. So which means that it will go to the else part, and this particular thing will return whatever, since the OK 0, whatever this G and then 2 is returning, right? So it will return whatever G2 is returning. So what about G2? G2 will create one another ANS which will point to 8 bytes, right? 8 bytes in memory, and G2 will actually return this ANS. So basically this particular pointer is not being returned. So if you are doing this free only one time, see, you did the malloc 2 times, once in G1, once in G2, right? You did the malloc 2 times, once in G1, once in G2, but you are freeing only G2. So this much memory you are not freeing. So that's why this is memory leak of 4 bytes, right? Memory leak of how many bytes? 4 bytes. Okay. So we already talked about it in the lectures. So I think everyone got it. Great. Yeah, that's also a very good question. How many of you were able to solve it? This is related to Master's theorem, by the way. Okay. In Master's theorem also we have something like this. Okay. In Master's theorem also we have a comparison of two functions which are polynomially greater or not. So we have said like two functions, this fn is polynomially greater. Okay. Polynomially, I will say polynomially greater than gn. If you can say that that gn multiplied by some n power is still, I mean, if you even multiply some n power, then still fn is greater asymptotically. So what does this mean? In other words, you can say that fn upon gn. Okay, I mean, if you divide that, then it is basically, if n power epsilon, then fn is polynomially greater. Okay, at least. Okay, which means if it is greater than or equal to n power epsilon, okay, then by the definition it is a polynomially greater, right? Polynomially greater. Okay, so you can take the division n square and n upon log n. So do you think n square divided by n upon log n, what is this? This will be n log n. Is this greater than or equal to n power something? Yes, it is greater than or equal to n power 0.1. So it is a polynomially greater. What about 2 power n and n square? Let's just see 2 power n and n square, right? 2 power n and n square. Is this greater than some n power? Yes. See, 2 power n is too much greater. You can, or maybe in other words, you can write 2 power n is basically greater than or equal to even n cube, right? Which means it is greater than or equal to n square into something. Is this greater than or equal to n square into something? Yes, it is greater than or equal to n cube also, right? So n square into n power something? Yes, right? So that's why you can say this is answer. Is this asymptotically greater? Asymptotically we know it is already greater. N is polynomially greater than log n. Is this true that n is also polynomially greater? Polynomially greater basically means that it is greater than or equal to, n is greater than or equal to, n is not directly, basically you can say n is greater than or equal to log n. Can you multiply n power something? Maybe n power 0.1, right? Yes, so this will be n power 0.9. You can cancel it out. This will be 0.9, and 0.9 is definitely greater than log n. So that's why n is greater than or equal to log n. I mean the polynomially greater, right? So that's why A, B, C, D. Actually, many people have missed out this D. So D is also the correct answer. N is also polynomially greater than log n. Okay, as per the definition, right? Why? Because n is greater than or equal to. Okay, so here n is greater than or equal to log n into n power something. Is this true? Yes. Greater than or equal to here means asymptotically greater. Okay, asymptotically greater. Okay. Now, were you able to solve that question? What is the answer you were getting here? See, this will run anyway n time. Now, what about this? This will be multiplying by 2. So basically you can say it will run j equal to 1, j equal to 2, j equal to 3, and maybe for j equal, sorry, not for 3 actually, j equal to 2 power 2, and j equal to 2 power 3, and j equal to 2 power k. Okay, it will run like this. Now this is the case, right? So basically now for this it will run one time. then 2 time, then 2 power 2 time. I mean, it is running j time, right? So you can say this 2 power k is nothing but n. So 1 plus 2 square plus 2 power k. And since it is increasing GP, so last term will only matter, right? We have talked about it in asymptotic sense, last term will only matter. So it is 2 power k, right? So it is 2 power k because last term will only matter in increasing GP. So 2 power k is nothing but n. So 2 power k is nothing but n. So n times it will take, and into n here, right? Into n here. So what is the answer? N square is the answer, right? N into n square is the answer. Okay. I hope you were able to do it. So B is the correct answer here. Okay. Okay. So were you able to solve this question? So I think there are 2-3 questions are only remaining. Let's just quickly do them. Okay. So were you able to solve this question, this DFS question? What they're saying DFS on the directed graph with n vertices and n edges is guaranteed to find at least one backage. Let's take n equal to 3. Do guaranteed to find one backage? Let's just see. Let's suppose it is A, it is B, it is C. Okay. See here, the DFS, if you run the DFS, it will be A, B, and C, right? If you run the DFS, this is a cross edge, right? This is a cross edge, not the back edge. You guaranteed to find at least one back edge? No, that is not true. That is not true, right? DFS on the undirected graph. Okay, on the undirected graph, at least one back edge. See, if there are n vertices and n edges, then you must be having the cycle, right? You must be having the cycle. And cycle means, I mean, the usual cycle. So basically, they are saying undirected graph with n vertices and n edges is guaranteed to find at least one back edge. What do you think? Yes, right? So basically, if there are n vertices and n edges, so maybe something like this. Okay, let's suppose n vertices, which means n equal to 3. Okay, n vertices, I mean 3 vertices, 3 edges. Now here let's suppose this is A, this is B, this is C. So this is A, B, and then you will go to C. Then this edge is a back edge. Okay, because this is a cycle, right? Here the cycle is not there. If the cycle is there, then you will be having the back edge. But here the cycle is there. Cycle is guaranteed, right? Here the cycle is guaranteed. Hence the back edge is also guaranteed. Here the cycle is not guaranteed. No guarantee of cycle. That's why the back edge is also not guaranteed, right? No guarantee of cycle. No guarantee of back edge. Okay. Cycle and back edge is actually same. Okay. In any graph, either it is directed or it is undirected, cycle and back edge is actually same. DFS on undirected graph with n vertices and may find a cross edge. Do you really think? So basically B is the correct answer. Do you think that DFS on the undirected graph will find the cross edge? Do undirected graph has the cross edge? No, right? Undirected graph do not have the cross edge. It only have tree and back edge, right? Undirected graph only have tree and back edge. So basically C is wrong answer. Now, they are saying may find. Okay, can you find in the directed? Maybe if you are having, okay, maybe if you are having something like this, okay. What they want? They want cross edge. Okay, they want cross edge, right? So this is the cross edge. This is the example. So that's why I think B and D are the correct answer. Okay, B and D are the correct answer. See, this cross edge is not possible. Why? Like we have taken the very great video on DFS. You can just check out on the YouTube. We have already taken one very good session on the DFS. So you can check out that. So DFS, the cross edge is not possible, right? The cross edge is not possible in the undirected graph in DFS, right? Okay, no problem. Now let's just see this question. This is very interesting question. So what they're saying, that A is comprising 500 integers that are stored in main memory, and it is an integer aligned address, which means whatever is the main memory size, let's not worry about it. They are saying the block size is 256. Block size is 256 bytes. Then it means how many integers? If the integer size is 4 bytes, then it means 64 integers. So one block can have how many integers? One block can have 64 integers, isn't it? So one block can have 64 integers, right? Now what does this mean? That that let's suppose this is a block. Okay. If I want to store the integers, then how many integers I can store? 64 integers I can store. Now, if I want to store, let's suppose this is a main memory block. If I want to store the array, then they are saying that array has to be started. Okay, maybe let's suppose this is address number 0. Okay, hypothetically I'm saying this is address number, starting address is 4 or something. In between there will be address number 1. Okay, I mean byte number 1, byte number 2, like this. Can the array start from the byte number 1? The answer is no. The array has to be started. Array address, base address visualize the size of integer, which means array can start either at 0, either either a0 can be stored from here, or a0 can be stored from here. I mean, it's not like that a0 can be starting from here to here. I mean, it cannot be from here to here. Okay, a0 cannot be from here to here. That is given in the question, that it is integer aligned, right? The base address of the array is visualize the size of integer. So which means they are saying that a0 you can store here. Okay, a0 you can store here, a0 you can store here, and so on, right? A0 you can store here, or maybe here, like this, right? Now you tell me one thing. Okay, you just tell me one thing. Let's suppose this is the main memory. Let's suppose this is main memory. Let's suppose this is a block. Okay, this is one block in the main memory. You just tell me one thing here. If let's suppose this is the cache that I have. Okay, this is the cache that I have. This is one line, okay, in the cache, right? We have the lines in the cache which is equal to the block size. Suppose I access some element from this block. So won't I be putting the whole block itself? Right? I will be putting the whole block, right? So if I access any element from here, I will be putting the whole block. Which means even if I access this particular element, then also I will be putting the whole block completely here. You tell me, let's suppose the block size is, suppose, for example, the block size is, let's suppose 256 bytes or whatever, right? Tell me, let's suppose I'm accessing this element, okay? This is the last or maybe some element I'm accessing. Do you think that I will be starting from here? I will be putting 256 bytes in this, or the block only? What do you think? What do you think? See, will I be putting starting from this or this particular block? I will putting this particular block, isn't it? So the question is very easy only. The question is saying that here you can put 64 or 256 bytes means 64 integers, right? You can put 64 integers here. This is 64 integers, okay, in one block. Now where this a0 should be starting, such that this a0 and a15 both are in the same block. Okay, both are in the same block. See, suppose in some block, okay, suppose in some block you have 64 integers you can store. Okay, 64 integers you can store. Okay, 64 integers you can store. Now since there are 64 integers, you just tell me that if I store a0 here, will a15 means 16th element, right? A15 will get stored in the same block or a different block? See, a0 to a63 will be in the same block, right? If I store a0 here, isn't it? Is this okay? Now if you just tell me here, okay, if I store, let's suppose if I store a0 here, then where is a15? Somewhere here, isn't it? And this element will be a63, something like this. If I store a0 here, okay, suppose if I store a0 here, then where is a15? Somewhere here, isn't it? So what is this? Maybe a62, or let's not worry about it, whatever it is. What I'm saying that a15 will be in the same block. So which means even if I store a0 here, a0, let's suppose these are the 16 blocks, okay, 16 blocks. Even if I store a0 here, then also a15 will be in the same block, isn't it? These are the 16 integers. Okay, this is a space of 16 integers, isn't it? So even if I store this a0 here, then also the a15 will be in the same thing, isn't it? So what is the remaining space? I mean, how many integers is space? I think 48, right? 48 or 14, 48, right? So you store A0 here in any of this 48 position, then also A15 is here, or this position, which means 48 plus 1 positions are there, which is 49 positions in which you store this. Okay, you can store in 49 positions this A0 or the array starting of this array, such that this A0 and A15 both are in the same block. Okay, is this understood to everyone? So there are 48 plus 1, which is 49 positions, such that A0 and A15 are in same block, right? So that's what they're asking, that how many positions you can store such that they are in same block, or they have written, I mean the wordings might be different, but they are saying that at how many positions you can store A0 such that A0 and A15 are in the same block, or in other words, whenever you bring this block into the cache, okay, whenever you bring this whole block into the cache, when you will be getting, initially you will be getting miss of A0, that then only you are bringing, then at the next time for the A15 you get hit. So at how many positions you can do it, such that whenever you get A0 miss, on the next time you are accessing A15 you get hit. At how many positions? 49 such positions are there, right? 49 such positions are there. Okay, so Utkarsh is saying I have written by mistake 48. Okay, Utkarsh has written by mistake 48. Yeah, the silly mistakes can cost you 2 marks, right? It is a 2-mark question, so silly mistake can cost you 2 mark. I agree. Okay, so this is I mean, sometimes it happens, but don't worry about it. Okay, you will be able to overcome these mistakes, right? Eventually. Okay. Were you able to solve this question? How many possible values are here? How many possible values are here? Were you able to solve this question? See, if you are having 2 for loops, right? I mean, if there are 2 threads which are executing this for loops, something like this. Okay. Suppose something like this. This is this. Okay. Suppose something like this. There are two threads which are executing these for loops. Now, obviously you can have 6. I mean, there is no wonder about it. You can have 6, right? So you can have 3, 4, 5, 6. How? Maybe you can say that, okay, here this 3, 4, 5, 6, these 4 are possible. How? Can anyone tell me? Is 2 possible? Yeah, this is interesting. 2 is 2 possible, right? This is only interesting thing. So you just tell me, what did you mark? You mark 4 or 5 for this question number 62. What did you mark in the exam? You have marked 4 or 5. See, the only trick here is that is 2 possible or not. See, 2 is also possible. Let me just tell you how. Okay, 2 is also possible. See, interestingly, 2 is possible. Do you remember anyone from Go classes student? This type of thing, okay, this type of thing we have solved in the class. Do anyone remember? See, why 2 is possible? Let's just see why 2 is possible. Okay, let's just see this. See, what you can do. I mean, this is read, modify, write, right? Read, you will modify. These are called, I mean, RMW things, which is read, or maybe let me write in simple words. You will be basically, you can say load, add, and store, right? Something like this, right? Something like this. Okay. So here also, this is load, add, and store. Now what you can do, you can load 0. Okay, you can load 0, and you can waste all of this. Okay, you can definitely waste all of this. You load 0, 1, 2, 3, and then finally you overwrite this, right? Finally you overwrite this. Okay, which means 1, 2, 3. So basically 3 is possible. Okay, you load 0 and you hold it. Okay, you hold it, and then you finish it. Okay, you finish it. That's how 3 is possible. If you don't want to waste all of this, you just want to waste one of this, then also it is possible. I mean 4 is possible, 5 is possible, 6 is possible. Okay, so 3, 4, 5, 6 is possible, but is 2 also possible? Let's just see. And how the 2 is possible. Okay, so 3, 4, 5, 6 is possible. I hope that is okay to almost all of you. Now how this 6 is possible? See here. This 2 is possible. You load this. Now what you do? You say that okay, here also you load 0. Okay, here also you load 0. Now what you do, interestingly, I mean, okay, let's just do one thing. You load 0 here. Okay, you waste 2 of them. Okay, you waste 2 of them. Okay, waste 2 iterations. I mean, you run this. Okay, the last iteration, let's just keep the last iteration. Okay, so just a second. What how to will be possible? Okay, see, this is little interesting. What you need to do, you can waste these two, right? Waste these 2 iterations, and then keep last iteration. Okay, keep last iteration with you. Okay, now what you do, I mean, what you can do, this last thing might be saying that okay, this is, I mean, currently the value of total is 2, right? The value of total is 2. Now what you can do, you can just execute this once. Okay, this once. Now if you execute this once, the value of total will be from 2, it will be again 1, because you are doing this, right? Now you executed this once. Okay, once is done. Okay, once is done. Now you start this iteration and you keep hold on 1. Okay, you keep hold this value. Okay, hold this one. You hold this one, right? If you hold this one and then you do whatever you want to do, then the last iteration, if you complete here, then it will be 2. It will be 2, right? If you complete this last iteration, this will be 2. You can hold this one in the last iteration. This is the trick. Okay, you can hold this one in the last iteration. Understood? So basically you waste 2 iterations here, you load 0 here, and then you increment this one, right? You increment this one here, and then you hold that one here. Okay, you hold that one here. Got it? And then you can do whatever you want to do here. Then you will, I mean, at the end it will be just 2. Okay, 2 is also possible. So hence 2, 3, 4, 5 is possible. 5, 6 is possible. 5 values are possible actually. Okay. Is 1 possible? No. You have to execute this once, right? At least 2 is possible. At least 2 is possible. 1 is not possible. 0 is not possible. At most 6. So 2, 3, 4, 5, 6. Okay. At most 6. Right? Cool. Now, let's just do this question. I hope you were able to do this question, right? This is not very tough question. This is saying that A is 0, 0. I mean, starting from 0, 0 basically. A is anything from 0, 0, right? 1, 2, 3, 4, 5. Okay, starting from 0, 0, you send it to A. Anything from 0, 1, you send it to B, right? Anything from 0, 1, you send it to B. No, so someone is saying that okay, it is not given that preemption can happen here. Preemption can happen anywhere. Okay, I mean, if they are asking what are the possible values, right, in the single CPU machine, what are the possible values, then this is how it get executed, right? So I mean, this is the normal code, and this is the race condition is there. So race condition is definitely there, right? Okay, now you tell me that 0, 0 you will send to, I mean, starting from 0 you send to A, starting from 0, 1 you send to B. Now otherwise, okay, otherwise you send to C. Now they are saying that which of the following is the routing table? So correct routing table. So what is the answer here? A, B, C, D is the answer. See, A, B, C, D, yes, A, B, C, D is the answer. How? Because all of them are satisfying the same thing. Here, this is as good as saying on 0 you send to A. See, if something on is starting with 0, they are saying you send to A. 0, 1 you send to B, right? if something is, let's suppose, if something is starting from 0 1, you anyway sending it to B. Earlier also you were sending it to B. If something is starting from, let's suppose, 0 0, then also here also you're sending to A. Earlier also you're sending to A, right? If something is starting from 1, earlier also sending to C, now also sending to C. So basically you can check that all the options are equivalent to this particular routing table. Okay, all the options are equivalent to this particular routing table. So A, B, C, D are the correct answer. Okay, why A? Because see here, that here why A is the answer, because what you are doing here, you are saying if starting from 0, then you are sending to A. What if it starts from 0 1? See, if it starts from 0 1, at this point in time, it is matching here also, it is matching here also. But because of the longest, you are anyway sending it to B, right? Because of the longest, you are anyway sending it to B. So if you start from 0 1, you will send it to B here also, you are sending to B here also. Starting from 0 0, earlier also A, here also A. It should be exactly same, okay? It should be exactly same. It is exactly same basically, right? Okay. Okay. So can you explain B? Let me just explain B. See, here at 0 0 A. Here they are saying at 0, if it is starting from 0, then you are sending to B. See, let's suppose something is starting from 0. Then since if it is either, it will be 0 0 or 0 1. If it is 0 0, you are anyway sending to A. If it is 0 1, then it is only matching to B, right? Default it is C. So basically here also on 0 1 B, here also on 0 1 B. Here are you sending anything extra to B? See, on 0, where are you sending? If it is 0 0, anyway you are sending to A. If it is 0 1, anyway you are sending to B, isn't it? So on 0 0 A, on 0 1 B, yes, right? Nothing extra. Here on 0 0, either it is 0 0 0 or 0 0 1 on 0 0 A, right? Because either it will be 0 0 0 or 0 0 1. So if it is starting with 0 0, then you are sending to A. If it is starting with 0 1, then it is not matching with anyone. That is why you are sending to B. So that's why, like, I mean, here 0 0 A, 0 0 0 1 B. Here also the same thing, right? And nothing extra. So similarly 0 0 A and okay. So I think they have just combined these two, right? I mean, the C and D are same, right? C and D are same. Okay, C and D are same. Nothing extra. This was a good question, isn't it? This was a good question. Okay. So you just tell me, how was the overall feedback of the questions? Tell me, have you learned anything from this question? Okay. Have you learned anything? From this AIMT? If that is the case, then after this video, okay, not currently, after this video, please comment, okay? Please comment if you have enjoyed this session. If you have loved it, then just let us know, okay? We have solved many good questions. This question was good, okay? And yeah, many easy questions also, and some conceptual, some good questions. So I think overall it must be a great experience, right? Okay, so just let us know in the comment if you have loved the session, if you have loved the AIMT. Let us know in the comments. Okay, so this question actually I just put the framing like that okay, goodbye to 2023 and eagerly waiting for 2024. So by the way, happy new year to everyone, right? Happy new year, and enjoy your evening. And sorry that we have put the test here, because yesterday there was too many requests that 30th of December we should not put the test, so that's why we have put the test today. Okay, so almost every question was very good. This question also, this particular question actually, right, this table is actually covering many questions, right? Many gate questions. This is very conceptual question, so we have covered many conceptual questions here. Okay, so just I hope you enjoyed everything, and this sorting and everything, right? So this sorting and everything, just let us know in the comments later. Okay. Okay. Please tell optimal marks. So I think if you are getting, I think 50, okay, 50 plus, okay, in this test, then it is very good. I think, okay, 50 plus marks should be very good here. Okay, at least you should be getting 50 plus, right? 50 plus marks should be very good, right? If you are getting 50 plus, it is a very good marks, right? Okay, if you are getting 50 plus, then it is really a very good marks. So just let us know in the comments that how you like this session. Okay, just comment it out. Okay, just comment if you have loved it, right? Just please comment. Yeah, thank you everyone. Thank you so much. Take care, and we will be conducting more AIMTs. You just have to give them. You just have to understand the questions. You just have to revise. Okay. So soon we will be having a general session telling you that what to do, what not to do currently. Okay. Soon we will be having general session. Okay. Great. So thank you everyone. Take care. Bye bye.